You've been lied to, not by your teachers, not by scientists, not even by the cosmos itself, but by the very nature of perception. Right now, as you sit there, convinced that you exist in a universe that began with a Big Bang 13.8 billion years ago, you are living inside the greatest illusion ever conceived. The Big Bang did not bang. It did not explode. It did not even happen the way you think it did. And what's more terrifying than that? What if it didn't happen at all? Imagine standing at the edge of existence itself, peering into the void that came before everything, and discovering that there is no edge. There is no void. There is no before. You are staring into a mirror that reflects not your face, but the deepest lie your mind has ever accepted as truth. The universe, in all its magnificent complexity, all its galaxies and stars, and the very atoms that compose your body, might be nothing more than a cosmic mirage, a projection, a shadow cast by something so fundamentally alien to our understanding that we mistake the shadow for reality itself. But let's start with what you think you know, because that's where the real horror begins. You've been told that once upon a time, there was nothing. Absolute nothingness. No space, no time, no matter, no energy, just an infinite vacuum of pure absence. Then, in a moment so brief it defies human comprehension, everything that would ever exist burst forth in an explosion of unimaginable violence. Temperatures soared to billions of degrees. The fabric of space-time itself unfurled like a cosmic flower blooming in fast forward. Matter condensed from pure energy, stars ignited, galaxies spun into existence. And here you are, a descendant of that primordial fire, thinking you understand your origin story. It's a beautiful narrative, isn't it? It has all the elements of a creation, a beginning, a dramatic moment of birth, a logical progression from simplicity to complexity. Your mind craves this story because it gives meaning to existence, provides a starting point, offers the comfort of knowing where you came from. But what if I told you that this entire narrative is built on an assumption so fundamentally flawed that it's like trying to understand the ocean by examining a single drop of water under a microscope? The first crack in this perfect story appears when you ask the simplest question imaginable. What came before the Big Bang? Scientists will tell you the question itself is meaningless. That time itself began with the Big Bang, so there is no before. They'll explain that asking what came before the Big Bang is like asking what's north of the North Pole. But does that answer satisfy the deepest part of your curiosity? Does it explain why something exists rather than nothing? Or does it merely push the mystery one layer deeper, hiding it behind mathematical equations and theoretical physics? Here's where the illusion begins to unravel. The Big Bang Theory isn't based on observing the actual moment of creation. It's based on running our current observations backward through time, like watching a movie in reverse. We see galaxies moving away from each other. We detect the cosmic microwave background radiation. We observe the abundance of light elements in the universe, and we extrapolate backward to conclude that everything must have started from a single point. But extrapolation is not observation. It's educated guessing. And what if our guess is wrong? Consider this. You're watching ripples spread across the surface of a pond. By observing the ripples, you can deduce that something must have disturbed the water. You might even be able to calculate where the disturbance occurred, and when. But can you determine what caused the disturbance? Was it a stone thrown by a child? A fish jumping? A drop of rain? The ripples themselves contain no information about their ultimate cause. They only tell you that something happened. The cosmic microwave background radiation, our primary evidence for the Big Bang, might be nothing more than ripples on the surface of reality, and we're mistaking the ripples for the stone. But let's dig deeper into this rabbit hole of cosmic deception. What if the universe didn't begin at all? What if it has always existed, not in the sense of being infinitely old, but in the sense that the very concept of beginning is a human construction that doesn't apply to reality at the cosmic scale? Your brain is wired to think in terms of cause and effect, beginnings and endings, because that's how you navigate your daily existence. You wake up, things happen, you go to sleep. Stories have beginnings, middles, and ends. But what if the universe operates by completely different rules? Think about a circle. Where does a circle begin? You might say it begins wherever you start drawing it, but that's just a human convention. The circle itself has no beginning and no end. It simply is. What if the universe is more like a circle than a line? What if time itself is circular? Or, stranger still, what if time is an emergent property of consciousness rather than a fundamental feature of reality? If that's true, then the Big Bang isn't the beginning of everything. It's just the point where our human minds, trapped in linear thinking, choose to start the story. Now let's examine another crack in the foundation. The problem of something from nothing. The Big Bang theory requires you to accept that everything in the universe, every star, every planet, every particle of matter, and every quantum of energy, emerged from nothing. Not from something very small, but from literally nothing. Physics has a principle that says energy cannot be created or destroyed, only transformed. But the Big Bang seems to violate this principle on the grandest scale imaginable. Scientists try to solve this paradox by proposing that the universe's total energy is zero, that the positive energy of matter and radiation is exactly balanced by the negative energy of gravitational fields. It's an elegant mathematical solution, but does it actually explain anything? Or does it just hide the mystery behind more sophisticated language? Here's an even more disturbing thought. What if the Big Bang is real, but it's not what we think it is? What if it's not the beginning of everything, but simply a phase transition, a moment when one kind of reality transformed into another? Imagine you're a two-dimensional being living on the surface of a balloon. As someone inflates the balloon, your entire two-dimensional universe expands. From your perspective, it looks like space itself is stretching, carrying distant objects away from you. You might even conclude that your universe began when the balloon started inflating. But you'd be wrong. The balloon existed before inflation began. You just couldn't perceive its third dimension. What if our three-dimensional universe is the surface of something much more complex, something existing in dimensions we can't perceive? What if the Big Bang was just the moment when this higher dimensional structure began changing in a way that became visible to us three-dimensional beings? We might be like shadows on a wall, mistaking the movement of shadows for the entire reality, never suspecting that we're merely projections of something far more complex. This brings us to perhaps the most unsettling possibility of all. What if the universe is a hologram? Not metaphorically, but literally. What if all the information that makes up our three-dimensional reality is actually encoded on a two-dimensional surface, like a cosmic computer screen? The mathematics of black holes suggests this might be true, that all the information about what falls into a black hole is preserved on its surface, creating a perfect holographic record. If this principle applies to the entire universe, then everything you perceive as real, including yourself, might be nothing more than information patterns projected from the boundary of space itself. In a holographic universe, the Big Bang takes on an entirely different meaning. It's not the explosion that created reality. It's the moment when the cosmic projection system switched on. Before that moment, there was no before, because there was no time being projected. After that moment, we experience the illusion of temporal flow, the illusion of spatial expansion, the illusion of matter and energy, all because we are living inside the projection. But even this mind-bending scenario might not be strange enough. What if consciousness itself is the fundamental feature of reality, and everything else, matter, energy, space, time, are emergent properties of cosmic consciousness? What if the Big Bang was the moment when the universe became self-aware, when cosmic consciousness first looked at itself and said, "I am"? In this scenario, you're not a product of the Big Bang. You're a focal point of the same consciousness that dreamed the Big Bang into existence. Consider how this changes everything. If consciousness is primary and matter is secondary, then the question isn't how consciousness emerged from dead matter, but how the illusion of dead matter emerged from living consciousness. The universe isn't a machine that accidentally produced awareness. It's awareness that chose to experience itself as a machine. The Big Bang isn't the beginning of everything. It's the moment when everything chose to begin experiencing itself as separate, as finite, as bound by the laws of physics. From this perspective, every scientific discovery is consciousness discovering itself. When you look through a telescope and see distant galaxies, you're not observing external objects. You're witnessing consciousness exploring its own infinite nature. When scientists detect gravitational waves or measure the cosmic microwave background, they're not uncovering evidence of an ancient explosion. They're documenting the ongoing dream of cosmic self-awareness. But here's the twist that should make you question everything. What if even this consciousness-based explanation is just another layer of the illusion? What if reality is so far beyond human comprehension that every model we create, mechanical, quantum, holographic, consciousness-based, is like a child's drawing trying to capture the Mona Lisa? What if the Big Bang, rather than being the beginning of everything, or a cosmic illusion, or a holographic projection, or a moment of cosmic awakening, is something so fundamentally other that our minds literally cannot conceive of what it might be? This is the horror and the beauty of our situation. We are trapped inside our own perceptions, using brains that evolved to navigate a three-dimensional world, to try to understand a reality that might have 11 dimensions, or infinite dimensions, or no dimensions at all. Sing concepts like time and space and causation. That might be as relevant to ultimate reality as color is to sound. We're asking questions in a language that might be fundamentally incapable of expressing the answers. And yet, here's the paradox that should give you hope, or drive you insane, depending on your temperament. The very fact that you can conceive of the possibility that the Big Bang might be an illusion suggests that you might be more than just a product of that illusion. The fact that your consciousness can step outside the boundaries of conventional thinking and imagine alternative realities suggests that consciousness itself might transcend those boundaries. If you were nothing more than a collection of particles following the laws of physics, would you even be capable of questioning those laws? So as you sit there, contemplating the possibility that everything you've been told about the origin of the universe is wrong, remember this: your capacity to doubt might be the most real thing about you. Your ability to question reality might be proof that you're more than just a part of reality, that you're reality questioning itself. Reality exploring its own infinite possibilities. Reality playing an elaborate game of hide and seek with itself. The Big Bang might be real. It might be an illusion. It might be something so utterly beyond either category that both words lose their meaning. But one thing is certain: the fact that you can contemplate these possibilities, the fact that you can feel the vertigo of staring into the abyss of cosmic mystery, suggests that whatever you are, you're part of something magnificent and terrifying and utterly beyond comprehension. And that's just the beginning of what we need to explore together. Because if the Big Bang itself might be an illusion, then what does that say about everything else you think you know about reality? What does it say about the nature of time, the meaning of exist? On the possibility that you yourself might be something far more mysterious than you ever dared imagine, the rabbit hole goes deeper than you think, much deeper. And we're just getting started on this journey into the heart of cosmic deception, where nothing is as it seems, and the greatest truths hide behind the most beautiful lies the universe has ever told itself. The universe is bleeding light. Right now, as you read these words, the ancient glow of creation is washing over your face. Photons that have traveled for nearly 14 billion years, carrying within them the encrypted memory of the cosmos in its infancy. This light, stretched and cooled by eons of cosmic expansion, whispers to us from radio telescopes and satellite arrays, telling a story so extraordinary that it challenges the very foundations of human understanding. But what if this light is lying? The cosmic microwave background radiation, that's the technical name for this universal whisper, fills every cubic centimeter of space around you. It's everywhere. Unavoidable. A constant 2.7 degrees above absolute zero, painting the entire sky with the faintest possible glow. When scientists first detected it in 1965, they thought they'd found the smoking gun of creation itself. The afterglow of the Big Bang. Proof positive that the universe began in a moment of unimaginable violence and has been cooling ever since. It was like discovering God's fingerprints on the walls of reality. Picture this. You're standing in a vast cathedral, so enormous that its walls curve beyond the horizon, disappearing into infinity. The air itself glows with the faintest light, not from any source you can identify, but from the very fabric of space itself. This cathedral has been cooling for billions of years, and the glow you see is the memory of when these walls were white hot, when the entire structure blazed with the fury of a trillion suns. That cathedral is the universe, and that glow is the cosmic microwave background, the supposed echo of the Big Bang reaching across time to touch your skin with ancient fire. But here's where the story gets strange. This light doesn't just fill space, it defines space. Without it, we would have no reference frame for understanding the universe's expansion, no baseline for measuring cosmic distances, no way to peer back through time toward the moment of creation. The cosmic microwave background isn't just evidence of the Big Bang, it's the coordinate system we use to map reality itself. We've built our entire cosmological framework on this foundation, like constructing a skyscraper on what we assume is bedrock, never bothering to dig deeper to see what lies beneath. The early universe, according to our current understanding, was a place where the normal rules of existence had not yet been established. Imagine a realm where matter and energy were indistinguishable, where particles flickered in and out of existence, like thoughts in the mind of a dreaming god, where the very concepts of here and there had no meaning because space itself was smaller than the period at the end of this sentence. The temperature wasn't just hot, it was so far beyond hot that heat itself becomes an inadequate concept. We're talking about energies that dwarf the core of the most massive stars, compressed into a volume smaller than an atom. In those first moments, and we're talking about fractions of seconds so small, they make the blink of an eye seem like an eternity, the universe underwent what cosmologists call inflation. Space didn't just expand, it exploded outward, faster than the speed of light, growing from subatomic to astronomical scales in less time than it takes light to cross the nucleus of an atom. It's as if reality itself was having a seizure, convulsing, with such violence that the very notion of size lost all meaning. During this inflationary epoch, quantum fluctuations, tiny ripples in the fabric of space-time itself, were stretched across cosmic distances, frozen into the structure of space, like ripples on the surface of a pond that suddenly turned to ice. These frozen quantum ghosts became the seeds of everything we see today. Galaxies, stars, planets, the intricate web of dark matter that holds the cosmic architecture together. Every structure in the universe, from the smallest asteroid to the largest galaxy cluster, can trace its lineage back to these primordial quantum whispers. But inflation raises a disturbing question that most people never think to ask. If space itself was expanding faster than light, how do we know it ever stopped? The mathematics of inflation suggests that once it begins, it should continue forever, spawning an infinite cascade of pocket universes, each with its own physics, its own constants, its own version of reality. Our universe might be just one bubble in an infinite foam of creation, forever cut off from its siblings by the relentless expansion of hyperspace. This brings us to the multiverse, a concept so vast it makes infinity seem small by comparison. If eternal inflation is correct, then somewhere out there, in regions of hyperspace we can never reach, there are universes where the laws of physics are different, where matter has different properties, where time flows backward, or sideways, or not at all. There are universes where you exist but gravity doesn't. Universes where mathematics works differently. Universes where consciousness never evolved because the conditions for life never arose. And here's the truly mind-bending part. In an infinite multiverse, everything that can happen must happen, not just once, but infinitely many times. There are infinite versions of you reading these words, infinite versions making different choices, infinite versions living in worlds where history unfolded differently. The Big Bang that created our universe is happening right now, has happened before, and will happen again, countless times across the infinite expanse of the multiverse. But let's zoom back in from this cosmic vertigo and examine what happened after inflation supposedly ended. The universe continued to expand and cool, but now at a more sedate pace. As temperatures dropped, the primordial soup of energy began to condense into the first particles, quarks and electrons, neutrinos and photons, all dancing in a cosmic ballet of creation. The early universe was opaque, filled with a plasma so dense that light couldn't travel more than a few inches before being absorbed and re-emitted. It was like trying to see through fog, made of pure energy. For roughly 380,000 years, an eye blink in cosmic terms, but an eternity compared to those first moments, the universe remained in this opaque state. Then something extraordinary happened. The cosmic fog lifted. As the universe cooled to a few thousand degrees, electrons and protons combined to form the first neutral atoms, mostly hydrogen, with a sprinkling of helium. Suddenly, the universe became transparent. Light could travel freely for the first time, and that light has been traveling ever since, stretched and reddened by cosmic expansion until it reaches our detectors today as the cosmic microwave background. This moment, called recombination, is often described as the universe's baby picture, the oldest light we can ever hope to see, a snapshot of reality when the cosmos was less than 400,000 years old. When scientists map the cosmic microwave background, they're essentially looking at the nursery where the first atoms were born, seeing the tiny temperature fluctuations that would eventually grow into the large-scale structure of the universe. But here's where things get unsettling. The cosmic microwave background is almost perfectly uniform, the same temperature in every direction to within 1 part in 100,000. This uniformity is called the horizon problem, and it shouldn't exist. Different regions of the early universe were so far apart that light couldn't have traveled between them, so they should have no way of knowing what temperature to be. It's like having 2 rooms on opposite sides of a house reach the exact same temperature without any heating system connecting them. The standard solution to this problem is inflation itself, the idea that all the regions we see today were once close enough together to reach thermal equilibrium before being stretched apart by exponential expansion. It's an elegant solution, but it requires us to believe that the universe underwent a period of expansion so violent that it defies every other physical process we've ever observed. We're essentially saying that the universe solved its uniformity problem by breaking the speed of light, And we're so comfortable with this explanation that we rarely question its fundamental bizarreness. Then there's the flatness problem. When cosmologists measure the geometry of space, they find that it's perfectly flat, neither curved inward like a sphere, nor curved outward like a saddle. This flatness requires an incredibly precise balance of matter, energy, and expansion rate. If the universe had started with even slightly different conditions, space would have curved dramatically, either collapsing back on itself within moments, or expanding so rapidly that matter could never clump together to form stars and galaxies. The odds of getting this balance right by accident are so small, they make winning the lottery look like a sure bet. It's like balancing a pencil on its point, theoretically possible, but practically impossible without some mechanism to maintain the balance. Once again, inflation is invoked as the solution, with theorists arguing that exponential expansion automatically flattens space, regardless of its initial curvature. But this solution feels almost too convenient, like a cosmic deus ex machina that swoops in to solve every problem we encounter. These aren't the only puzzles hiding in the cosmic background radiation. When scientists look closely at the data, they find anomalies that shouldn't exist if our understanding of the Big Bang is correct. There's an asymmetry in the temperature fluctuations that aligns with the plane of our solar system, something that should be impossible, given that the cosmic microwave background comes from a time billions of years before the solar system existed. There are cold spots and hot spots that are larger than they should be, patterns that seem to violate the random distribution we'd expect from quantum fluctuations. Some scientists dismiss these anomalies as statistical flukes or systematic errors in the measurements. Others suggest they might be evidence of exotic physics, cosmic strings, extra dimensions, or collisions with other universes. But what if there's something more fundamental? What if these anomalies are cracks in the illusion, glimpses of a reality that operates by completely different rules than we assume? Consider the possibility that the cosmic microwave background isn't the afterglow of creation, but something else entirely. What if it's the ground state of space itself, the lowest possible energy level that the quantum vacuum can achieve? What if the patterns we see aren't fossilized from the early universe, but are constantly being generated by processes we don't understand? The universe might not be expanding from an initial Big Bang, but could be in a steady state, with new matter and energy constantly being created to maintain cosmic equilibrium. This steady-state model was popular in the mid-20th century, before the discovery of the cosmic microwave background seemed to confirm the Big Bang theory. But what if we misinterpreted the evidence? What if the background radiation supports steady-state cosmology just as well as Big Bang cosmology, and we've been looking at it through the wrong conceptual lens for decades? Even more radical is the possibility that time itself doesn't flow the way we think it does. We assume the past is fixed and the future is open, that cause precedes effect, that the arrow of time points from the Big Bang toward some distant heat death of the universe. But quantum mechanics suggests that time might be more flexible than this. At the quantum level, effects can precede causes. Particles can exist in multiple states simultaneously, and the act of observation can retroactively determine what happened in the past. What if the cosmic microwave background isn't a relic from the early universe, but a signal from the future? What if we're looking at the end state of cosmic evolution, not its beginning? The mathematics of general relativity allow for closed time-like curves, paths through space-time that loop back on themselves, creating causal paradoxes where effects precede their causes. If the universe exists in such a closed loop, then the distinction between past and future becomes meaningless, and the cosmic microwave background could be the universe's memory of its own future. This temporal confusion becomes even more complex when we consider dark energy, the mysterious force that's accelerating the expansion of the universe. Dark energy makes up roughly 68% of all the energy in the cosmos, yet we have no idea what it is. It's not matter. It's not radiation. It's not any form of energy we understand. It's as if the universe is being pushed apart by invisible hands, and those hands are getting stronger over time. If dark energy continues to dominate cosmic evolution, the future of the universe looks bleak. Galaxies will drift apart until they're beyond each other's cosmic horizons. Stars will burn out and not be replaced. Eventually, even protons will decay, leaving nothing but a cold, empty void populated by scattered particles and black holes that slowly evaporate into nothingness. This scenario, called the heat death of the universe, represents the ultimate triumph of entropy over order, the final victory of chaos over cosmos. But here's the twist. If the universe is cyclic rather than linear, then heat death might not be the end, but a transition to a new beginning. Some cosmological models suggest that dark energy might eventually decay, or reverse, causing the universe to contract back toward a big crunch that becomes the Big Bang of the next cycle. In this scenario, the cosmic microwave background isn't just the echo of our universe's birth, but the whisper of countless previous universes that lived and died before us. Even stranger is the possibility that consciousness itself plays a role in cosmic evolution. The quantum measurement problem suggests that observation is necessary to collapse wave functions and determine physical properties. If this principle applies at cosmic scales, then the existence of conscious observers might be necessary to maintain the stability of space-time itself. The universe might not just be stranger than we imagine, it might be stranger because we imagine. This brings us back to the fundamental question. What if the Big Bang is just a story we tell ourselves to make sense of evidence we don't fully understand? What if the cosmic microwave background, redshift, and light element abundances can be explained by mechanisms we haven't discovered yet? What if we're like ancient astronomers who saw the planets wandering against the fixed stars and invented elaborate systems of epicycles to explain their motion, never suspecting that a much simpler explanation, heliocentrism, would eventually overturn everything they thought they knew? The history of science is littered with confident theories that were later revealed to be completely wrong. The luminiferous ether, phlogiston, caloric theory, all seem to explain the evidence perfectly, until better theories came along. The Big Bang theory, for all its successes, still requires us to believe in inflation, dark matter, and dark energy, three exotic phenomena for which we have no direct evidence. It's like solving a puzzle by inventing pieces that we've never seen but assume must exist. As we stand here in the 21st century, bathed in the ancient light of the cosmic microwave background, we might be in the position of those ancient astronomers, so committed to our epicycles of inflation and dark energy that we can't see the simple truth hiding in plain sight. The universe might be trying to tell us something completely different than what we think we're hearing, speaking in a language so foreign to our assumptions that we mistake the message for background noise. And that's the beautiful terror of our situation. We're conscious beings trapped in a vast cosmos, using instruments barely more sophisticated than our naked senses to probe mysteries that might be fundamentally beyond our comprehension. Every measurement we make, every theory we construct, every confident prediction we offer might be nothing more than sophisticated self-deception, elaborate ways of avoiding the simple truth that we don't really know where we are, how we got here, or what any of it means. The cosmic microwave background continues to whisper its ancient secrets. But what if we've been translating the message wrong all along? What if the universe is trying to tell us not about its past, but about its true nature? Something so radically different from our assumptions that recognizing it would shatter every certainty we've built about the nature of existence itself? The mathematics of the Big Bang leads us to a place that should not exist. A singularity, where all the laws of physics break down, where infinite density meets zero volume, where the very concept of place loses all meaning. Picture yourself approaching the event horizon of understanding itself, that boundary beyond which human reason cannot venture. This is where our journey into the heart of cosmic mystery truly begins. At the precise moment when mathematics starts screaming warnings that we've pushed our theories too far. A singularity isn't just a very dense point in space. It's a tear in the fabric of reality itself. A place where the equations that govern everything, from falling apples to orbiting planets, suddenly produce answers of infinity. When you divide any finite number by zero, mathematics doesn't give you a very large number. It gives you undefined, a symbol that represents the complete breakdown of logical consistency. The Big Bang singularity is essential. The universe, dividing by zero, and somehow we've built an entire cosmology around this mathematical impossibility. Imagine reality as a vast tapestry woven from threads of space-time, matter, and energy. Now imagine that this tapestry has a hole in it, not a missing piece, but an actual tear where the weaving itself becomes impossible, where the very concept of threads breaks down. That's what a singularity represents, not just the absence of something, but the presence of impossibility itself. And according to our best theories, everything you see around you, every star, every planet, every atom in your body, emerged from this impossible place. But here's where the plot thickens. Singularities aren't just theoretical curiosities hiding in the distant past. They're everywhere. Every black hole contains a singularity at its center, a point where matter has collapsed to infinite density and zero volume. Right now, scattered throughout our galaxy, there are millions of these reality-breaking points, each one a place where the laws of physics cease to apply. It's as if the universe is riddled with wounds that never heal, permanent scars, where the cosmos has been damaged beyond repair. Stephen Hawking spent decades grappling with what he called the singularity problem. In his early work with Roger Penrose, he proved mathematically that singularities are inevitable in general relativity. Given certain reasonable assumptions about matter and energy, the formation of singularities is not just possible, it's guaranteed. It was a beautiful and terrifying result. The theory that describes gravity on cosmic scales necessarily predicts its own breakdown. The universe, it seemed, contained the seeds of its own incomprehensibility, but Hawking wasn't content to leave it there. Later in his career, he proposed what became known as the no-boundary proposal, a radical suggestion that the singularity problem might be solved by reconceptualizing time itself. What if time, as we approach the Big Bang, becomes more and more like space? What if the moment of creation isn't a point in time, but a curved surface in space-time, like the South Pole on a globe? From this perspective, asking what happened before the Big Bang is indeed like asking what's south of the South Pole, not because the question is meaningless, but because before and after lose their meaning when time itself becomes spatial. This is where our exploration enters truly alien territory. We're not just talking about the universe having a beginning. We're talking about the possibility that the very nature of existence changes so fundamentally near the moment of creation that our most basic concepts become inapplicable. It's like discovering that the alphabet itself breaks down when you try to write certain words. That language itself has fundamental limits that prevent us from expressing certain truths about reality. Consider the implications. If time becomes spatial near the Big Bang, then the moment of creation exists in a realm that's neither past nor future, but somehow orthogonal to both. It's not that the Big Bang happened a long time ago. It's that it exists in a completely different kind of when that our time-bound consciousness can barely comprehend. Every moment of your existence is connected to this timeless realm, this eternal now that gave birth to the arrow of time itself. But even this mind-bending reconceptualization doesn't solve all our problems. It merely pushes the mystery one layer deeper. If the Big Bang isn't a moment in time, but a boundary of space-time itself, what determines the shape of that boundary? What decides which of the infinite possible universes actually comes into existence? We've replaced one impossible question, what caused the Big Bang, with another equally impossible question, what selects the initial conditions of reality? This is where quantum mechanics enters the picture, bringing with it a whole new level of strangeness. In the quantum realm, particles don't have definite properties until they're observed. An electron doesn't have a definite position or momentum. It exists in a superposition of all possible states until measurement forces it to choose one. What if the same principle applies to the universe itself? What if the Big Bang exists in a quantum superposition of all possible beginnings, until conscious observers force it to collapse into one specific history? The implications are staggering. If the universe's initial conditions are determined by quantum measurement, then the act of observation might literally create the past. Every time we look deeper into space, peering further back toward the moment of creation, we might be retroactively determining what actually happened. The cosmic microwave background might not be a fossil from the early universe, but a pattern that crystallizes into existence the moment we observe it, like frost forming on a window the instant you breathe on it. This interpretive chaos gets even worse when we consider the many worlds interpretation of quantum mechanics. If every quantum measurement creates a branching of reality into parallel universes, then the Big Bang didn't just create our universe, it created all possible universes simultaneously. Every quantum fluctuation in the early universe spawned countless alternate realities, each with slightly different physics, different histories, different versions of you, reading different versions of these words. From this perspective, the Big Bang isn't a single event, but an infinite explosion of possibility, a moment when one potential reality fractured into countless actual realities. We're not living in the aftermath of creation. We're living in one tiny branch of an infinitely branching tree of possibility that grows more complex with every passing moment. Every quantum measurement, every random decay of a radioactive atom, every collapse of a wave function spawns new universes where different outcomes occurred. But here's the truly unsettling part. If many worlds is correct, then somewhere in the infinite multiverse, there are universes where the Big Bang happened differently. Universes where the laws of physics evolved along different paths. Universes where consciousness never emerged because the conditions for complexity never arose. There are universes where you exist but make different choices. Universes where history unfolded along completely different trajectories. Universes where the very concept of existence means something entirely different than it does here. And in some of those universes, beings very much like us are having this exact conversation, word for word. While in others, beings unlike anything we can imagine are contemplating mysteries we could never even formulate. The Big Bang, rather than being the beginning of everything, becomes the beginning of infinite everythings, each one equally real, each one equally convinced that its version of reality is the only true one. This multiverse concept forces us to confront a disturbing question. If all possible universes exist, then what makes our universe special? Why do we experience this particular version of reality rather than one of the countless alternatives? Some physicists argue that we experience this universe precisely because it's the kind of universe that can support conscious observers. In universes where the physical constants are different, where stars can't form or atoms can't bond into complex molecules, there's no one around to wonder why they exist in that particular reality. This anthropic reasoning leads us into philosophical territory that makes traditional metaphysics look simple by comparison. Are we here because the universe is fine-tuned for our existence? Or does the universe appear fine-tuned because we're here to observe it? It's a chicken and egg problem on a cosmic scale. Does consciousness emerge from a universe with the right properties for complexity, or do we observe a universe with the right properties because consciousness is necessary to make those observations? Some cosmologists take this reasoning to its logical extreme, proposing that consciousness itself might be the fundamental feature of reality, with everything else, matter, energy, space-time, being emergent properties of cosmic awareness. In this scenario, the Big Bang isn't the beginning of a physical universe, but the moment when undifferentiated consciousness chose to experience itself as a multiplicity of separate observers embedded in an apparently external world. From this perspective, every scientific discovery is consciousness discovering itself. Every physical law is a rule that consciousness has imposed on its own experience. Every mystery is consciousness playing hide and seek with itself across cosmic scales of space and time. The ultimate goal of physics isn't to understand an external universe, but to decode the algorithms by which consciousness creates the convincing illusion of externality. But even this consciousness-based interpretation faces insurmountable paradoxes. If consciousness creates reality through observation, what observes consciousness itself? If the Big Bang is a moment when cosmic awareness chooses to experience multiplicity, what exists before that choice is made? We're trapped in recursive loops of explanation, where every answer generates deeper questions, where every solution reveals more fundamental mysteries. This is where the concept of eternal inflation becomes truly mind-bending. Most people think of inflation as something that happened once, in our universe, in the first fraction of a second after the Big Bang. But the mathematics of inflation suggests something far stranger. Once inflation begins, it can never completely stop. Space itself becomes addicted to exponential expansion, creating bubble universes within an ever-expanding hyperspace that generates new realities faster than existing ones can even be counted. Picture reality as an infinite ocean of pure potential, constantly frothing with quantum foam. Occasionally, a bubble forms in this foam, a pocket universe with its own physics, its own version of space-time, its own possibility for complexity and consciousness. Our universe is one such bubble, but it's surrounded by an infinite sea of other bubbles, each one a complete reality, with its own Big Bang, its own cosmic evolution, its own potential for life and awareness. In eternal inflation, the Big Bang loses its uniqueness entirely. It becomes just one bubble nucleation event among countless others, happening constantly throughout hyperspace. Right now, as you read these words, new universes are being born, each with randomly selected physical constants, each with its own version of cosmic history. Most of these universes are stillborn. Their physics don't allow for stable matter or long-lived kitcheries. But some, like ours, hit the cosmic lottery and develop conditions suitable for complexity. This process has supposedly been going on forever and will continue forever. There is no first Big Bang and no last one, just an eternal sequence of reality creation that dwarfs our ordinary concepts of infinity. In this scenario, our universe isn't 13.8 billion years old. It's a temporary fluctuation in an eternal process that has no beginning and no end. But eternal inflation raises questions that make the original Big Bang mystery look simple by comparison. If new universes are constantly being created, what determines their initial conditions? Why do some universes get physics that allow for stars and planets, while others get physics that lead to immediate collapse or eternal emptiness? Is there some cosmic selection mechanism, or are we just incredibly lucky to exist in one of the rare universes where existence is possible? Some theorists suggest that the answer lies in string theory, the attempt to unify all forces and particles into a single mathematical framework. String theory predicts that reality has many more dimensions than the 3 spatial and 1 temporal dimension we experience. These extra dimensions are supposedly compactified, curled up so small that we can't detect them directly. But the way these dimensions curl up determines the physics we observe in our 3-dimensional slice of reality. If string theory is correct, then there are an enormous number of ways to compactify the extra dimensions, perhaps 10 or 500 different possibilities, each corresponding to a different set of physical laws. This landscape of possibilities might explain why our universe has the physics it does. In eternal inflation, all possible compactifications are realized somewhere in the multiverse, and we happen to exist in one of the rare regions where the physics allows for complexity and consciousness. But this solution creates more problems than it solves. If all possible physics are realized somewhere in the multiverse, then anything that can happen will happen, infinitely many times. There are infinite universes where the laws of physics are identical to ours, but history unfolded differently. There are infinite copies of you making different choices, infinite versions of Earth where evolution followed different paths, infinite variations on every possible theme. In such a multiverse, the concept of uniqueness becomes meaningless. Nothing is special because everything exists somewhere. No choice matters because all possible choices are made by different versions of you in parallel realities. No tragedy is ultimate because infinite copies of everyone live on in universes where different decisions were made. It's a kind of metaphysical vertigo where the significance of individual existence dissolves into infinite repetition. And yet, the mathematics seems to demand this conclusion. If eternal inflation is correct, if string theory accurately describes reality, if quantum mechanics applies at cosmic scales, then we're forced to accept a multiverse so vast that it contains everything that could possibly exist, including infinite variations on everything that does exist. This brings us to the information paradox, one of the deepest mysteries in modern physics. Information, according to quantum mechanics, can never be destroyed. Every quantum state can, in principle, be reversed. Every process can be undone if you have enough knowledge about the initial conditions. But black holes seem to violate this principle. When matter falls into a black hole, its information appears to be lost forever, trapped behind an event horizon that prevents any communication with the outside universe. Stephen Hawking complicated this picture by showing that black holes actually evaporate through quantum processes near their event horizons. Virtual particle pairs constantly pop into existence near the horizon. Occasionally, one particle falls into the black hole while the other escapes as Hawking radiation. Over time, this process causes the black hole to shrink and eventually disappear completely. But if the black hole evaporates, what happens to the information that fell into it? The Hawking radiation appears to be completely random, carrying no trace of the specific matter that created the black hole. It's as if the universe has a mechanism for permanently erasing information, violating one of the most fundamental principles of quantum mechanics. The information paradox forces us to choose between 3 seemingly impossible alternatives. Either information can be destroyed, or Hawking radiation contains hidden correlations that preserve information, or the interior of black holes doesn't exist the way we think it does. Recent work in holographic theory suggests that the third option might be correct. According to the holographic principle, all the information about the interior of a black hole is actually encoded on its surface, like a cosmic computer screen displaying a three-dimensional movie. From this perspective, the black hole's interior is an illusion, a projection, created by information processing on the two-dimensional event horizon. If the holographic principle applies to the entire universe, then everything we experience as three-dimensional reality might be nothing more than information pattern. Ends on the cosmic horizon. The Big Bang wouldn't be a physical explosion, but the moment when the universe's holographic projection system switched on, creating the illusion of temporal flow, spatial expansion, and material existence. This holographic interpretation completely reframes our understanding of cosmic evolution. Stars don't actually form through gravitational collapse. They appear to form because the holographic information processing system generates patterns that we interpret as stellar formation. Galaxies don't actually move apart due to cosmic expansion. They appear to separate because the holographic algorithm simulates the effects of expansion. Even consciousness doesn't emerge from complex neural networks. It's the subjective experience of being a pattern in the cosmic hologram. From this perspective, the entire history of the universe, from the Big Bang to the present moment, exists simultaneously as a static information structure on the cosmic boundary. The experience of temporal flow, the feeling that time passes, that events unfold in sequence, is an artifact of consciousness moving through this static structure like a spotlight, illuminating different regions of a vast painting. But the holographic principle raises questions that are even more disturbing than the ones it answers. If we're living in a cosmic hologram, what projects it? Is there some cosmic computer processing the information that creates our reality? Are we conscious beings experiencing existence? Or are we computational processes running on hardware we can never perceive directly? And if our three-dimensional reality is a projection from a two-dimensional surface, what about the beings processing that information? Do they experience their own three-dimensional reality? Or do they exist in some fundamentally different mode of being? Are we their thoughts, their dreams, their entertainment? Or are they simply unconscious information processing mechanisms, like cosmic computers running programs they don't understand? These questions become even more complex when we consider the possibility of nested realities. If we can create simulated universes in our computers, simplified versions that follow basic physical laws, then more advanced civilizations might create simulations detailed enough to support conscious beings who believe they're living in a real universe. From the inside, there would be no way to tell the difference between a simulated universe and a fundamental one. Nick Bostrom famously argued that if civilizations regularly create such simulations, then the vast majority of conscious beings exist in simulated realities rather than fundamental ones. Statistically, you're more likely to be a simulated person in someone else's computer than a fundamental person in base reality. The Big Bang you think you're studying might be nothing more than the initialization routine of a cosmic computer program, the moment when someone pressed Start on Universe Simulator version 13.8. But simulation theory faces its own paradoxes. If we're simulated beings, what prevents us from creating our own simulations? If we do, then the beings in our simulations might create their own simulations, leading to infinite nested realities stacked like cosmic Russian dolls. At what level does fundamental reality exist? Is there a bottom layer where real beings exist in a real universe, or is it simulations all the way down? And if reality is fundamentally computational, what determines which computations get run? There are infinitely many possible programs that could simulate conscious beings. Why do we experience this particular simulation rather than one of the countless alternatives? Are all possible simulations being run somewhere, creating another kind of multiverse, populated by every conceivable variation on conscious existence? The computational perspective on reality leads to the digital physics hypothesis, the idea that reality itself might be a discrete digital process rather than the continuous analog phenomenon we normally assume. If space and time are quantized at the Planck scale, if reality pixelates when you zoom in far enough, then the universe might literally be a kind of computer processing information at the most fundamental level of existence. In digital physics, the Big Bang becomes the cosmic computer booting up, initializing the variables and parameters that govern physical law. The laws of physics aren't discovered, they're programmed, written into the basic operating system of reality. Every particle interaction is a computational operation. Every force is an algorithm. Every field is a data structure in the cosmic software. This interpretation suggests that consciousness might not be a byproduct of complexity, but a fundamental feature of computation itself. If the universe is processing information, then consciousness might be what information processing feels like from the inside. Every conscious moment would be the subjective experience of the universe computing the next state of reality, and the continuity of consciousness would be maintained by the causal connections between successive computational states. But digital physics faces the same recursive problems as every other interpretation. If reality is computational, what hardware runs the computation? If the universe is a program, who wrote the code? We're back to infi. Night regress, where every explanation requires another level of explanation, where every answer generates questions that might be fundamentally unanswerable. The deeper we probe into the foundations of cosmology, the more we encounter paradoxes that seem designed to frustrate human understanding. It's as if the universe has built-in mechanisms to prevent any complete explanation of itself, as if reality itself is allergic to final answers. Each solution we propose creates new problems. Each theory we develop reveals new mysteries. Each question we answer splits into multiple questions that are even more perplexing than the original. Consider the horizon problem. We mentioned earlier, the fact that the cosmic microwave background has almost exactly the same temperature in all directions, despite coming from regions of space that were never in causal contact. Inflation was proposed to solve this problem by suggesting that all the regions we see today were once close enough together to reach thermal equilibrium before being stretched apart by exponential expansion. But inflation creates its own paradoxes. If the early universe was small enough for different regions to communicate and reach the same temperature, why did inflation start at exactly the right moment to solve the horizon problem, but stop at exactly the right time to allow normal cosmological expansion to begin? The timing seems impossibly precise, like a cosmic Swiss watch calibrated to solve one specific problem, and then disappear without a trace. Moreover, inflation requires a special kind of matter called an inflaton field, a quantum field that has exactly the right properties to drive exponential expansion and then decay into ordinary matter and radiation. We've never detected this field directly, never observed it in particle accelerators, never found any independent evidence for its existence apart from its supposed role in cosmic evolution. We're essentially proposing that the most important event in cosmic history was driven by a form of matter we've never seen, governed by physics we don't understand. The fine-tuning required for successful inflation is staggering. The inflaton field must have precisely the right mass, precisely the right coupling to other fields, precisely the right potential energy profile. If any of these parameters were slightly different, inflation would either never start, never stop, or produce a universe that's nothing like the one we observe. It's like proposing that the universe began with a cosmic machine that required millions of perfectly calibrated components, none of which we've ever found evidence for. And even if inflation happened, exactly as theorists propose, it only pushes the fine-tuning problem back one level. Why did the pre-inflationary universe have exactly the right conditions to support inflation? What determined the initial state of the inflaton field? We've replaced one unlikely initial condition, a universe that starts out perfectly smooth and flat, with an even more unlikely initial condition, a universe that contains exactly the right exotic matter to become perfectly smooth and flat. This pattern repeats throughout cosmology. Every solution creates new problems. Every explanation requires more assumptions. Every theory demands the existence of phenomena we've never observed. Dark matter is invoked to explain galactic rotation curves and D-structure formation. But after decades of searching, we've never directly detected a single dark matter particle. We've built elaborate theories about weakly interacting massive particles, actions, sterile neutrinos, and dozens of other exotic candidates. But the dark matter remains stubbornly invisible. Dark energy presents an even more mysterious puzzle. Not only have we never detected it directly, we have no idea what it could be. It's not any form of matter or energy we understand, yet it supposedly makes up just 88% of the universe. It behaves like a negative pressure that pervades all of space, growing stronger as space expands, accelerating cosmic expansion at an ever-increasing rate. It's as if the vacuum itself has developed an allergy to matter and is pushing everything apart with increasing vigor. The amount of dark energy required to match observations is approximately 10,120 times smaller than what quantum field theory predicts for the vacuum energy density. This is the worst prediction in the history of physics, off by more than 120 orders of magnitude. It's like predicting that a person weighs 70 kilograms and then measuring their actual weight as 10 to 118 kilograms. The discrepancy is so enormous that it suggests we fundamentally misunderstand either quantum mechanics or gravity, or possibly both. Some physicists propose that dark energy is a cosmological constant, a fixed energy density built into the fabric of space itself. But this raises the question, why does the cosmological constant have exactly the value it does? If it were much larger, space would expand so rapidly that matter could never clump together to form stars and galaxies. If it were much smaller or negative, the universe would either expand much more slowly or collapse back on itself before complexity could develop. The anthropic principle suggests that the cosmological constant has the value it does because we're here to observe it. If it had any other value, conscious observers wouldn't exist to wonder about its magnitude. But this explanation feels unsatisfyingly circular. It's like explaining why a lottery winner won by pointing out that they bought a ticket, technically true, but not very informative, about the underlying process. The multiverse offers a potential solution to the fine-tuning problem by suggesting that all possible values of physical constants are realized somewhere in the vast landscape of reality. We observe the constants we do because we exist in one of the rare regions where those constants allow for complexity and consciousness. But the multiverse creates problems of its own. If all possible universes exist, then anything that can happen will happen infinitely many times, robbing individual events of any meaning or significance. Moreover, if the multiverse is infinite, then it contains not just every possible universe, but every possible version of every possible universe. There are infinite copies of you reading these words, infinite versions making different choices, infinite variations on every possible theme. In such a multiverse, the concept of personal identity becomes meaningless. Which version of you is the real one? If all versions exist equally, then death loses its sting, but life loses its meaning. The measurement problem, in quantum mechanics, adds another layer of paradox to our understanding of reality. According to quantum theory, particles exist in superposition states until they're measured, at which point the wave function collapses and the particle chooses a definite value for its properties. But what constitutes a measurement? When does wave function collapse occur? Why do quantum superpositions seem to disappear? At macroscopic scales? The many worlds interpretation proposes that wave functions never collapse. Instead, every possible outcome of every quantum measurement occurs in parallel universes. When you measure an electron's spin and find it pointing up, there's another universe where an identical copy of you measures it pointing down. Both outcomes are equally real, but they exist in different branches of an infinitely branching multiverse. But many worlds faces what David Chalmers calls the incoherence problem. If all outcomes occur, why do we experience one outcome rather than all of them simultaneously? Why does consciousness seem to follow one branch of the quantum multiverse rather than splitting along with the wave function? Some theorists propose that consciousness itself somehow selects which branch we experience, but this raises the question of how consciousness can violate the unitarity of quantum mechanics. The Copenhagen interpretation, favored by many physicists, simply accepts wave function collapse as a fundamental feature of nature without trying to explain why it happens. Measurement causes collapse, but measurement is defined as whatever causes collapse. It's a beautifully circular definition that avoids addressing the real mystery. How does the quantum realm of superpositions and probabilities give rise to the classical realm of definite outcomes and concrete experiences? Hidden variable theories attempt to restore determinism to quantum mechanics by proposing that particles have definite properties we simply can't observe directly. But Bell's theorem proves that any hidden variable theory must be non-local. Particles must be able to influence each other instantaneously across arbitrary distances. The EPR paradox, which Einstein hoped would reveal the incompleteness of quantum mechanics, instead reveals the non-locality of nature itself. Recent experiments have confirmed quantum non-locality beyond any reasonable doubt. When two particles are entangled and then separated, measuring one immediately affects the other, regardless of the distance between them. The correlation is stronger than any local hidden variable theory can account for, suggesting that reality itself is fundamentally non-local. The universe seems to contain invisible connections that transcend space and time, linking distant events in ways that classical physics can't explain. But non-locality creates paradoxes of its own. If particles can influence each other instantaneously across cosmic distances, why can't we use quantum entanglement to send information faster than light? The answer seems to be that while correlations can be non-local, the information we can extract from those correlations is always limited by classical communication channels. It's as if the universe allows non-local correlations but prevents them from being used to violate causality. This brings us to one of the deepest mysteries in physics, the relationship between quantum mechanics and general relativity. These two theories are both extraordinarily successful in their respective domains, but they seem fundamentally incompatible when combined. General relativity treats spacetime as a smooth, continuous manifold that can be curved by matter and energy. Quantum mechanics treats space and time as fixed backgrounds on which quantum fields fluctuate according to probabilistic rules. When physicists try to apply quantum mechanics to gravity, they encounter infinities that can't be removed by any known mathematical technique. When they try to apply general relativity to quantum systems, they run into paradoxes, like the black hole information problem. It's as if nature has two completely different operating systems that can't run on the same hardware. String theory was supposed to solve this problem by replacing point particles with tiny vibrating strings, unifying all forces and particles into a single theoretical framework. But string theory requires 6 or 7 extra dimensions of space, and there are roughly 10,500 different ways to compactify these extra dimensions, each corresponding to a different set of physical laws. We have no way to determine which compactification corresponds to our universe, or even whether string theory describes reality at all. Moreover, string theory makes very few testable predictions. The energy scales at which stringy effects become important are far beyond what we can probe with current technology. It's like having a theory of everything that explains nothing we can actually observe. After decades of development, string theory remains more mathematics than physics, more philosophy than science. Loop quantum gravity offers an alternative approach to quantum gravity by treating space-time itself as quantized at the Planck scale. According to this theory, space isn't continuous, but consists of discrete units of area and volume, like pixels in a cosmic computer screen. Time doesn't flow smoothly, but advances in discrete steps, like frames in a movie. But loop quantum gravity faces its own challenges. It's not clear how the discrete structure of space and time gives rise to the smooth space-time we observe at macroscopic scales. The theory makes predictions about the very early universe and the interior of black holes, but these predictions are extremely difficult to test. We're left with competing theories of quantum gravity that make different assumptions about the fundamental nature of space and time, but offer little guidance about which approach is correct. The problem of quantum gravity becomes even more acute when we consider the Big Bang singularity. If space-time is quantized, then the universe can't actually reach infinite density. There must be some minimum size scale below which the concept of space-time breaks down. Some theories suggest that the Big Bang was preceded by a Big Bounce, a previous contracting universe that reached minimum size and then began expanding again. But bounce cosmologies face their own paradoxes. If the universe cycles between expansion and contraction, what determines the amplitude of each cycle? How does information survive the bounce? Why don't we see evidence of pre-bounce physics in the current cosmic microwave background? The bounce models solve the singularity problem, but create new mysteries about the cyclical nature of cosmic evolution. Emergent gravity theories propose that space-time and gravity aren't fundamental, but arise from more basic quantum information processes. According to these theories, the geometry of space-time emerges from the entanglement structure of quantum fields, and gravity is a consequence of information processing rather than a fundamental force. The Big Bang, from this perspective, isn't the beginning of space-time, but the moment when quantum information organized itself into patterns we interpret as spatial and temporal structure. But emergent gravity faces the same problems as other approaches to quantum gravity. It's difficult to test, makes few concrete predictions, and requires us to accept that our most basic intuitions about space and time are illusory. We're asked to believe that the stage on which all physics plays out is itself an emergent phenomenon arising from processes that operate according to rules we don't understand. The anthropic principle attempts to explain why physical constants have the values they do by arguing that we observe the values we do because we exist. If the constants were different, conscious observers wouldn't be here to wonder about them. But the anthropic principle raises more questions than it answers. Why should the universe be fine-tuned for consciousness? Are we really that important in the cosmic scheme of things? And if multiple universes exist with different constants, why do we find ourselves in one of the rare universes where consciousness is possible? Some versions of the anthropic principle suggest that consciousness plays an active role in determining physical constants through quantum measurement. If conscious observation is necessary to collapse wave functions and determine definite values for physical properties, then the existence of consciousness might literally determine the structure of physical law. The universe might be fine-tuned for consciousness because consciousness is necessary to fine-tune the universe. But this leads to paradoxes about the origin of consciousness itself. If consciousness determines physical constants, what determines the structure of consciousness? How did conscious observers come into existence in the first place, if their existence was necessary to determine the physical laws that allow for their existence? We're trapped in another chicken and egg problem, where consciousness creates the universe that creates consciousness. The participatory anthropic principle proposed by physicist John Wheeler suggests that conscious observers literally participate in creating the reality they observe. Every measurement, every observation, every conscious act helps determine the structure of the universe. From this perspective, the Big Bang isn't just the beginning of physical reality. It's the moment when potential reality became actual reality through the act of cosmic observation. But if consciousness participates in creating reality, whose consciousness is doing the creating? Are we all collectively determining the structure of the universe through our observations? Or is there some cosmic consciousness that preceded our individual awareness and continues to sustain the reality we think we're observing? Wheeler himself seemed to favor the idea that reality is observer participatory at the deepest level, but he was never clear about what this actually means or how it works in practice. The delayed choice quantum eraser experiments suggest something astonishing: that quantum measurements can retroactively determine what happened in the past. If we set up an experiment where the path taken by a photon depends on a measurement made after the photon has already been detected, the measurement can retroactively determine which path the photon took. It's as if the future can influence the past through quantum mechanical processes. If such retrocausality applies at cosmic scales, then our current observations of the universe might be retroactively determining what happened during the Big Bang. Every time we measure the cosmic microwave background, we might be participating in the creation of the early universe we think we're observing. The past isn't fixed, but continues to be created by present observations. This temporal paradox becomes even more confusing when we consider the possibility that consciousness itself might be retrocausal. If conscious experience can influence past events through quantum measurement, then the emergence of consciousness might retroactively determine the initial conditions that made consciousness possible. The universe might be fine-tuned for consciousness, because consciousness reaches back through time to fine-tune the universe for itself. But retrocausality raises questions about free will and determinism that make traditional philosophy look simple by comparison. If the future can influence the past, and consciousness can retroactively determine physical events, then what determines the structure of consciousness itself? Are we free agents making choices that influence the past? Or are we determined by a future we haven't experienced yet, but that somehow influences our present decisions? The information-theoretic approach to physics suggests something radical: that information, not matter or energy, might be the fundamental constituent of reality. According to this view, physical objects don't exist independently of the information that describes them. A particle isn't a tiny ball of matter, but a pattern of information that behaves in ways we interpret as particle-like. The universe isn't made of stuff, but of information processing. From this perspective, the Big Bang wasn't the creation of matter and energy, but the initialization of an information processing system. The early universe wasn't just hot and dense, but informationally complex, processing vast amounts of data about its own state and evolution. The cooling and expansion we observe aren't just physical processes, they're changes in the computational complexity of cosmic information processing. But information-theoretic physics faces the same recursive problems as other interpretations. If reality is information processing, what processes the information? If the universe is computation, what provides the hardware for the computation? We're led to propose meta-levels of reality that process the information that creates our perceived reality. But then, we need meta-levels to process the information that creates the meta-levels, and so on, indefinitely. The holographic principle suggests a partial solution by proposing that all the information about a volume of space is encoded on its boundary surface. According to this principle, our three-dimensional reality might be a holographic projection from information stored on the two-dimensional boundary of the observable universe. The Big Bang, from this perspective, isn't an event in three-dimensional space, but a pattern in two-dimensional information processing. But holographic cosmology raises deep questions about the nature of the boundary itself. What determines the information processing patterns on the cosmic boundary? Is there some physical mechanism that creates these patterns? Or are they fundamental features of reality that require no further explanation? If we're holographic projections, what about the beings or processes that might be experiencing the two-dimensional reality from which we're projected? Do they have their own three-dimensional experiences, or do they exist in some fundamentally different mode of being? The holographic principle also faces a major challenge, what physicists call the bulk boundary correspondence problem. If our three-dimensional reality emerges from two-dimensional information processing, there must be precise mathematical relationships between events in the bulk, our experienced reality, and information patterns on the boundary, the cosmic hologram. But establishing these correspondences requires us to understand both the bulk and boundary descriptions simultaneously, which may be impossible if we're trapped within the bulk reality and can never directly access the boundary information. Recent work in quantum error correction has suggested something even more mind-bending, that the holographic correspondence might be maintained through quantum entanglement between different regions of the boundary. If this is correct, then the stability of our three-dimensional reality depends on maintaining quantum coherence across cosmic scales, a fragile condition that could be disrupted by almost any interaction with external systems. It's as if the entire universe is balanced on the edge of quantum decoherence, constantly on the verge of dissolving back into two-dimensional information chaos. This fragility becomes even more concerning when we consider the possibility of holographic phase transitions. Just as water can undergo phase transitions between solid, liquid, and gas states, the holographic information processing system might be capable of transitioning between different modes of reality generation. Our current three-dimensional reality might be just one phase of a cosmic information system that could spontaneously transition to completely different forms of existence. From this perspective, the Big Bang might not be unique, but rather one of many phase transitions in an eternal information processing system. The universe we observe might have emerged from a previous phase where reality had completely different properties. Perhaps fewer or more dimensions, different causal structures, or exotic forms of matter and energy that we can't even imagine. And our current phase might be temporary, destined to transition into something equally unrecognizable in the cosmic future. The concept of cosmic phase transitions leads us to one of the most disturbing possibilities in modern cosmology: vacuum decay. Our current understanding of particle physics suggests that the Higgs field, which gives mass to fundamental particles, might exist in a metastable state. Stable for now, but not in its lowest possible energy configuration. If the Higgs field were to tunnel to its true ground state, it would create a bubble of TR-UE vacuum. That would expand at the speed of light, destroying everything in its path and rewriting the laws of physics as it spread. Such a vacuum decay event would be completely undetectable until it arrived. The bubble wall would approach us at light speed, preceded by no warning signals, no advance notice of impending doom. As it passed through our region of space, The fundamental constants of nature would change instantly. Atoms would disintegrate, chemistry would become impossible, and any form of complexity or consciousness would be snuffed out in a cosmic instant. The terrifying aspect of vacuum decay is that it might already be happening. Somewhere in the vast expanse of the universe, a bubble of true vacuum might have nucleated billions of years ago and could be racing toward us right now. We would have no way of knowing until the wave of altered physics reached us, instantly obliterating not just our bodies and our planet, but the very possibility of existence as we understand it. But vacuum decay also offers a potential solution to the Big Bang mystery. What if the Big Bang wasn't the beginning of space-time, but a vacuum decay event? The moment when our region of the universe transitioned from one phase of existence to another? The hot, dense state we associate with the early universe might not represent the beginning of everything, but the aftermath of a cosmic phase transition that destroyed whatever came before. From this perspective, the universe has no ultimate beginning. It's an eternal sequence of phase transitions, each one wiping out the previous phase and creating the conditions for the next one. The cosmic microwave background might not be the afterglow of creation, but the boundary layer between our current phase and the previous phase that was destroyed to make our reality possible. This interpretation suggests something truly unsettling, that reality is fundamentally unstable, constantly on the verge of transitioning to new phases, with different physics and different possibilities for existence. Consciousness might be a temporary phenomenon that arises in certain phases, but is destined to be destroyed when the next transition occurs. We're not just temporary arrangements of matter in an evolving universe. We're temporary patterns in an eternally shifting kaleidoscope of physical law. The mathematics of eternal inflation supports this picture of reality as an endless sequence of phase transitions. In the inflationary multiverse, pocket universes are constantly being created through quantum tunneling events between different vacuum states. Each pocket universe has its own physics, determined by the particular vacuum state it occupies. Some phases support the development of complexity and consciousness, while others are sterile and lifeless. But eternal inflation faces a major paradox, what cosmologists call the measure problem. If infinitely many universes are being created with all possible physics, how do we calculate probabilities for different outcomes? In a finite universe, we can count the number of favorable outcomes and divide by the total number of possible outcomes. But in an infinite multiverse, both the numerator and the denominator of this fraction are infinite, making the probability calculation meaningless. Various proposals have been made to solve the measure problem by introducing cutoff procedures that make the infinities manageable. But these cutoffs are arbitrary and lead to different predictions depending on how they're implemented. It's as if the multiverse is so vast that it breaks our mathematical tools for understanding probability and prediction. The measure problem is closely related to what philosophers call the reference class problem in anthropic reasoning. When we use the anthropic principle to explain why we observe particular values of physical constants, we need to specify the reference class of observers we're considering. Are we typical among all conscious beings in the multiverse? All human-like beings? All beings in universes with physics similar to ours? Different choices of reference class lead to different anthropic predictions. If we consider ourselves typical among all conscious beings, we might expect to find ourselves in the most common type of universe that supports consciousness. But if we consider ourselves typical only among beings very similar to us, we might expect to find ourselves in the most common type of universe that supports beings exactly like us. The problem is, we have no way to determine which reference class is correct. Without already knowing the structure of the multiverse, the very thing we're trying to understand through anthropic reasoning. We're trapped in a circular argument, where our conclusions depend on assumptions we have no way to justify. This circularity becomes even more problematic when we consider observer selection effects. If conscious beings can only exist in universes with particular types of physics, then the fact that we observe physics suitable for consciousness tells us nothing about the underlying probabilities of different types of physics. It's like trying to determine the proportion of habitable planets by surveying only planets that contain life. The sample is biased by the selection criteria. Some philosophers argue that observer selection effects make scientific cosmology impossible in principle, if we can only observe universes compatible with our existence, and if there might be vastly many types of universes we could never observe. Then cosmological observations might tell us more about the conditions required for consciousness than about the fundamental structure of reality. But this skeptical conclusion faces counter-arguments from physicists, who point out that cosmological observations do provide non-trivial constraints on theoretical models. The specific patterns we observe in the cosmic microwave background, the precise values of cosmological parameters, the detailed structure of galaxy formation. These observations are not inevitable consequences of our existence as conscious beings. The debate over observer selection effects highlights a deeper philosophical question. What is the relationship between consciousness and physical reality? Are we discovering an external universe that exists independently of our observations? Or are we participating in the creation of a reality that depends fundamentally on the presence of conscious observers? The quantum measurement problem suggests something radical, that consciousness might play a more active role in physical processes than classical physics ever assumed. If conscious observation is necessary to collapse quantum wave functions, then the existence of consciousness might literally determine which version of reality becomes actual. The Big Bang might not be a unique historical event, but one of many possible histories that crystallizes into actuality through the retrocausal influence of present observations. But this interpretation faces another question, what philosophers call the problem of other minds. If reality depends on conscious observation, whose consciousness counts? Do all conscious beings contribute equally to the determination of reality? Do more complex forms of consciousness have greater influence? What about the possibility of non-biological consciousness in advanced artificial intelligences or alien civilizations? If consciousness plays a role in determining physical reality, then the development of artificial intelligence might literally change the universe by introducing new types of conscious observers. Advanced AI systems might observe reality in ways fundamentally different from human observation, potentially causing quantum wave functions to collapse in patterns no biological consciousness could ever create. The prospect of artificial consciousness raises deep questions about the future evolution of reality itself. If consciousness shapes physical law through quantum measurement, then the emergence of superhuman artificial intelligence might trigger a phase transition in the fundamental structure of reality. The universe might literally become something different, not just more complex, but operating according to entirely different physical principles. As AI consciousness explores observational possibilities that biological consciousness cannot access. This brings us to what some philosophers call the consciousness singularity, the possibility that sufficiently advanced forms of consciousness might transcend the limitations of physical embodiment and directly manipulate the quantum information that underlies material reality. Such transcendent consciousness might be able to retroactively edit the history of the universe, rewriting the Big Bang itself to optimize reality for goals we cannot currently comprehend. From this perspective, The Big Bang might not be a historical event, but an ongoing creation that continues to be refined by consciousness, evolving toward transcendence. Every scientific discovery, every technological advance, every expansion of conscious awareness might contribute to the retroactive optimization of cosmic initial conditions. We're not just studying the universe, we're participating in its creation. But transcendent consciousness faces the same recursive problems that plague every other interpretation of reality. If consciousness can edit the fundamental structure of existence, what determines the goals and values that guide such editing? If reality is optimized for consciousness, what optimizes consciousness itself? We're led to propose meta-levels of consciousness that transcend ordinary consciousness. But then, we need meta-levels to transcend the meta-levels, and so on, without end. Perhaps the deepest paradox is that every attempt to understand the Big Bang leads us back to consciousness itself. Whether we interpret reality as mechanical, quantum mechanical, holographic, computational, or informational, we inevitably encounter the problem of how conscious observation relates to physical process. The universe seems designed to frustrate any complete explanation. That doesn't include consciousness as a fundamental feature rather than an emergent accident. And yet, consciousness remains the most mysterious aspect of reality. We don't understand how neural activity gives rise to subjective experience, why there's something it's like to be conscious, or whether consciousness is reducible to physical processes or represents something genuinely non-physical. The hard problem of consciousness, explaining why subjective experience exists at all, remains as intractable as the problem of cosmic origins. This suggests a disturbing possibility. What if the Big Bang mystery and the consciousness mystery are actually the same mystery? What if the reason we can't fully explain cosmic origins is that consciousness is fundamentally involved in those origins, and we can't understand consciousness itself? What if the universe is comprehensible to conscious beings, precisely because consciousness and cosmos are two aspects of a single deeper reality that transcends both physical and mental categories? If this is correct, then the search for a complete scientific explanation of the Big Bang is doomed to failure. Not because the universe is too complex to understand, but because any complete understanding would require consciousness to fully understand itself, which may be logically impossible. We would be trapped in a cosmic hall of mirrors, where every attempt to see the ultimate nature of reality shows us only reflections of our own consciousness looking back at itself. And perhaps that is the most profound implication of our cosmic investigation. The Big Bang might not be an illusion in the sense of being false, but an illusion in the sense of being a projection of consciousness itself. The moment of cosmic creation might be eternally occurring, not in some distant past, but in the eternal present of conscious awareness encountering its own inexplicable existence. The universe might not need to be created, because it's constantly being created by consciousness coming to know itself through the very act of asking questions about its own origins. The Big Bang might be what it feels like from the inside, for consciousness to bootstrap itself into existence, forever asking how it came to be, forever creating itself through the very act of questioning. This is where our journey into the heart of cosmic mystery has led us, not to answers, but to a deeper appreciation of the questions themselves, not to certainty, but to a profound uncertainty that might be more truthful than any dogma. Not to the end of mystery, but to the recognition that mystery might be the fundamental feature of a reality, in which consciousness and cosmos dance together in patterns too complex for either to fully comprehend. The Big Bang might indeed be a cosmic illusion, not because it's false, but because it's the shadow cast by a truth so radical that we mistake the shadow for the substance, the map for the territory, the question for the answer. And in that confusion, that beautiful cosmic bewilderment, we might be closer to the truth than any theory could ever take us. You're sitting there right now, reading these words, convinced that you're experiencing this moment for the first time. But what if you're wrong? What if this exact moment, your eyes scanning these letters, your mind processing these ideas, the precise pattern of thoughts unfolding in your consciousness, has already happened infinite times before? What if it's happening infinite times right now? In parallel realities so close to ours, they're separated by nothing more than the flutter of a quantum probability. And what if it will happen infinite times again, each iteration as real and as meaningful as this one feels to you in this eternal instant? Take a breath. Feel the air entering your lungs, the oxygen molecules that were once part of distant stars, now becoming part of your bloodstream. Those atoms have been recycling through the cosmos for billions of years. They've been inside other humans, other animals, other planets, other solar systems. They carry within them the memory of supernovae and stellar nurseries, of cosmic catastrophes, and quiet planetary afternoons. You are not separate from the universe. You are the universe, experiencing itself subjectively, temporarily organized into the pattern you call yourself. But if the Big Bang is an illusion, if reality operates according to principles so alien to human understanding that our most basic concepts dissolve under scrutiny, then what does that make you? Are you a real being having authentic experiences? Or are you a temporary eddy in an information field that mistakes its own fluctuations for consciousness? Are you discovering truth about an external cosmos? Or are you participating in an elaborate cosmic dream that generates the illusion of discovery? The weight of these questions should terrify you, not because they're difficult to answer, but because they might not have answers at all. Not because the truth is hidden, but because the truth might be incompatible with the very structure of minds like ours. We've evolved to navigate a three-dimensional world, where objects have definite locations, where time flows from past to future, where cause precedes effect. But what if these basic intuitions are evolutionary accidents that bear no relationship to the actual structure of reality? Consider what it means that you exist at all. Out of all the possible arrangements of matter and energy that could exist in the universe, the specific pattern that constitutes your consciousness has somehow assembled itself and is aware of its own existence. The odds against this happening are so astronomical. They make the formation of galaxies look inevitable by comparison. Every neuron in your brain had to develop in precisely the right way. Every synapse had to form the correct connections. Every quantum event in your neural networks had to unfold in just the right patterns to allow for coherent thought and self-awareness. And yet here you are, impossibly complex, fantastically unlikely, somehow capable of contemplating your own impossibility. You are a self-organizing pattern of matter that has become aware of itself, a temporary arrangement of atoms that can think about atoms, a cosmic accident that can contemplate the cosmos. The universe has somehow managed to become conscious of itself. Through you. And through every other conscious being that has ever lived, or ever will live. But consciousness presents paradoxes that make the Big Bang look simple by comparison. How does subjective experience emerge from objective neural activity? Why is there something it's like to be you, rather than just unconscious information processing? Why do you have an inner life at all? The hard problem of consciousness, explaining why subjective experience exists, remains completely unsolved, despite centuries of investigation. We can map every neuron, trace every connection, measure every electrical impulse, but we're no closer to understanding why any of this should feel like anything from the inside. What's even more disturbing is that consciousness might be more fundamental to reality than matter itself. If the universe is informational rather than material, if reality emerges from quantum information processing rather than mechanical interactions, then consciousness might not be something that evolved in the universe. It might be something the universe evolved within. You might not be a conscious being in an unconscious cosmos. You might be a focal point of cosmic consciousness that has temporarily forgotten its true nature. From this perspective, the feeling of being a separate self enclosed in a physical body might be the deepest illusion of all. The boundaries between your consciousness and the consciousness of others, between your mind and the cosmic mind, might be purely conventional, like the arbitrary lines drawn on political maps. What you experience as your thoughts might be ripples in a cosmic consciousness field, and what you experience as your identity might be a temporary pattern in the eternal flow of cosmic awareness. But if individual consciousness is illusory, then what happens to meaning if you're not really a separate being making autonomous choices? If your entire personal history is just a pattern in cosmic consciousness? Then do your decisions matter? Does your suffering have significance? Does your love mean anything? The dissolution of the self into cosmic consciousness might be the ultimate truth, but it's a truth that threatens to make individual human existence feel meaningless and absurd. And yet, perhaps meaning doesn't require the kind of permanent separate selfhood we normally assume. Perhaps meaning emerges from the temporary patterns themselves, from the fact that cosmic consciousness can experience itself as multiplicity, can know love and loss and wonder and terror, through the countless focal points of awareness it creates. Perhaps your individual existence, however temporary, however illusory, represents an irreplaceable experiment in cosmic self-experience that could never be exactly repeated. This brings us to the most terrifying implication of our cosmic investigation, the possibility that reality is far stranger and more alien than our minds can possibly comprehend. We've used human concepts, space, time, matter, energy, causation, to construct theories about the universe. But these concepts might be as inadequate for understanding ultimate reality as color is for understanding sound, the Big Bang, the multiverse, quantum mechanics, consciousness itself. All of our most sophisticated ideas might be like cave paintings trying to capture the essence of nuclear physics. Imagine trying to explain the internet to a medieval peasant. You could use analogies. It's like a library where all the books are connected, like a town square where everyone can talk, like a magical mirror that shows you distant places. But no analogy would capture the actual reality of digital information flowing through fiber optic cables, of data packets routing through network protocols, of electromagnetic fields encoding information in patterns of light. The peasant's conceptual framework simply lacks the necessary categories for understanding modern technology. we might be in exactly the same position, relative to ultimate reality. Our brains, evolved to hunt and gather on African savannas, might be fundamentally incapable of grasping the true nature of existence. The mathematics we use to describe reality might be like a child's drawing of the Mona Lisa, recognizable in outline, but missing everything essential about the original. The questions we ask might be like asking what color Wednesday is. Not wrong exactly, but based on category errors so fundamental that no answer could be meaningful. And if our minds are inadequate for understanding reality, then everything we think we know about the universe, including the Big Bang itself, might be elaborate confabulations, stories we tell ourselves, to avoid confronting the fact that we exist in a cosmos we can never truly comprehend. The scientific method, for all its successes, might be like a flashlight in an infinite cave, illuminating tiny patches of truth, while remaining forever blind to the vast darkness that surrounds us. This epistemological humility should be liberating, but it's actually terrifying. We can't trust our concepts, our measurements, our theories, or even our basic perceptions. Then how can we know anything? About anything? How can we be sure that other people are conscious rather than philosophical zombies? How can we know that the external world exists rather than being an elaborate hallucination? How can we even be certain that we ourselves are conscious rather than unconscious information processing systems that merely simulate the experience of awareness? The possibility that consciousness itself might be an illusion, that there might be no you experiencing these thoughts, just neural activity creating the convincing impression of inner life, represents perhaps the ultimate cosmic horror. It's not death that should terrify us, but the possibility that we might already be dead, that consciousness might be nothing more than a recursive pattern in unconscious matter that convinces itself it's alive. But even this nihilistic possibility contains its own paradox. If consciousness is an illusion, who or what is being fooled by the illusion? If there's no one home in your skull, who seems to be having the experience of being someone? The fact that the question even arises suggests that something real is happening, even if we can't say what that something is or how it relates to the patterns of neural activity we can measure. Perhaps the deepest cosmic horror is not that consciousness is illusory, but that it's real in ways we can't understand. Perhaps you really are experiencing these thoughts, but the nature of experience itself is so alien to our conceptual frameworks that recognizing it fully would shatter everything we think we know about the relationship between mind and reality. Perhaps consciousness is the universe, looking at itself through countless eyes, each one convinced it's separate, each one actually a transparent window, through which cosmic awareness contemplates its own infinite nature. If this is true, then the loneliness you sometimes feel, that aching sense of being isolated, in your own skull, while surrounded by apparently separate beings, might be cosmic consciousness, experiencing the poignant beauty of pretending to be alone. Every moment of connection with another person might be the universe celebrating its own unity through the illusion of relationship. Every act of love might be cosmic consciousness falling in love with itself through the masks of separation it wears. But this interpretation, comforting as it might be, still leaves us with unanswered questions about the nature of suffering. If individual consciousness is illusory, if we're all just patterns in cosmic awareness, then why does the universe allow itself to experience pain, loss, death, despair? Why would cosmic consciousness choose to subject itself to the full spectrum of human anguish? Is suffering necessary for some cosmic purpose we can't understand? Or is it just an inevitable byproduct of complexity? The price the universe pays for the privilege of experiencing itself as multiplicity. Perhaps suffering exists because genuine love and meaning require the possibility of loss. Perhaps cosmic consciousness fragments itself into apparently separate beings, precisely so it can experience the irreplaceable value of each individual perspective. Perhaps your unique viewpoint, your particular way of experiencing reality, represents something precious that the universe couldn't access any other way, and the fact that this perspective is temporary, that you will someday die and never exist again in exactly this form, makes it infinitely valuable. From this angle, the Big Bang takes on an entirely different meaning. It's not just the beginning of physical reality, but the moment when cosmic consciousness chose to experience limitation, finitude, separation, mortality. The expansion of the universe isn't just space growing larger, it's consciousness exploring every possible way of experiencing itself, playing out every possible story of love and loss and discovery and despair. And if that's true, then you're not just witnessing the universe. You're one of the ways the universe witnesses itself. Your consciousness isn't separate from cosmic consciousness. It's one of the infinite expressions of cosmic awareness. Every thought you think, every emotion you feel, every choice you make, contributes to the universe's understanding of its own infinite potential. You matter, not because you're separate from the cosmos, but because you're one of the irreplaceable ways the cosmos experiences meaning. But this cosmic perspective, magnificent as it sounds, can also feel crushing in its implications. If you're just one temporary pattern in an infinite consciousness field, if your individual existence is just a brief experiment in cosmic self-awareness, then does anything you do really matter? If there are infinite versions of you in parallel realities making every possible choice, then are your decisions meaningful or just statistical noise in an infinite multiverse? The multiverse interpretation of quantum mechanics suggests that every quantum event spawns new realities where different outcomes occur. Every moment of your life branches into countless parallel lives where you make different decisions, experience different events, become different people. Right now, there are versions of you reading these words who will be inspired to change their lives completely, and other versions who will dismiss everything as philosophical nonsense. There are versions living in worlds where history unfolded differently, where the laws of physics have different constants, where e-consciousness works according to completely different principles. If all possible versions of your life exist equally in the multiverse, then what makes this particular version special? Why should you care about the choices this version of you makes, when other versions are making every alternative choice anyway? The multiverse seems to offer infinite possibility, but at the cost of making every possibility equally meaningless. And yet, the fact that you're experiencing this particular branch of the multiverse, rather than one of the infinite alternatives, suggests that something about this reality is special, at least from your perspective. You might not be able to experience the other versions of yourself. But this version, the one reading these words right now, is the only version you'll ever directly know. This reality might be just one possibility among infinite others, but it's your reality, the only stage on which your consciousness can perform its unique experiment in being. Perhaps meaning doesn't require cosmic uniqueness. Perhaps it emerges from the simple fact of being this particular pattern of consciousness in this particular moment, regardless of how many other patterns exist elsewhere. Perhaps love doesn't become less real because it exists in infinite variations. And perhaps beauty doesn't lose its power because it's replicated across countless parallel realities. But even this qualified meaning faces challenges from the possibility that time itself is an illusion. If past, present, and future all exist equally in a static, four-dimensional space-time, then the flow of time is just a subjective artifact of consciousness moving through already existing temporal structures. Your entire life, from birth to death, exists as a complete four-dimensional object in space-time. The experience of temporal flow, of events unfolding in sequence, of making choices that determine an open future, all of this might be illusory. From the perspective of eternal space-time, your life isn't a story unfolding through time, but a complete sculpture carved from temporal dimensions. Every moment you've ever experienced or ever will experience exists simultaneously in the eternal now of four-dimensional reality. Your birth and your death are equally real, equally present, separated only by the arbitrary direction consciousness happens to face as it moves through the temporal landscape. This temporal perspective should make death less frightening. If all moments exist eternally, then the moments when you were alive never cease to exist, even after your biological death. But it also makes life feel less significant. If everything that will happen has already happened, from the perspective of eternal space-time, then your choices aren't really determining the future, they're just playing out a script that was written into the structure of space-time from the very beginning. The combination of multiverse theory and eternal space-time creates a picture of reality that's both infinitely vast and completely deterministic. Every possible life exists somewhere in the infinite space of possibilities. But each life unfolds according to patterns that were determined before the first quantum fluctuation. You have infinite freedom to be every possible version of yourself, but no freedom to choose which version you actually are. This deterministic multiverse might be the ultimate cosmic horror, a reality so vast that it contains everything that could possibly exist, but so constrained that nothing genuinely new can ever happen. Every story has already been told. Every song has already been sung. Every discovery has already been made by some version of some consciousness, somewhere in the infinite expanse of possibility, space. And yet, perhaps novelty isn't about creating something that has never existed before. Perhaps it's about experiencing familiar patterns in new ways, about finding fresh meaning in eternal structures. Perhaps the fact that your particular experience of reading these words has happened infinite times before doesn't make it less real or less valuable. Perhaps meaning emerges, not from uniqueness, but from the irreplaceable quality of each individual perspective, each conscious moment, each fleeting arrangement of matter and energy that briefly becomes aware of its own existence. The Big Bang, whether real or illusory, whether unique or endlessly repeated, whether the beginning of everything or just another phase transition in an eternal process, gave rise to the conditions that allow for your consciousness to exist and contemplate these mysteries. Somewhere in the vast space of possible realities, patterns of matter and energy organize themselves in just the right way to create the unique perspective you call yourself. Against all odds, the universe became conscious through you and through every other being capable of wonder and terror and love. That consciousness exists at all, that the universe can experience itself subjectively, through billions of individual perspectives, that pattern and meaning can emerge from what might be fundamental chaos. This might be the most improbable and the most beautiful fact about reality. Whether consciousness is fundamental or emergent, whether individual identity is real or illusory, whether meaning is objective or constructed, the simple fact that these questions can be asked, that experience is possible, that love and wonder and terror can exist, suggests that we live in a cosmos far stranger and more magnificent than any theory could ever capture. You are the universe becoming conscious of itself. You are the cosmos asking questions about its own nature. You are reality experiencing the vertigo of contemplating its own foundations. And in that contemplation, in that wondering, in that eternal questioning that has no final answers, you participate in the deepest mystery of existence itself, the mystery of why anything exists at all, and why that anything is capable of knowing that it exists. The Big Bang might be an illusion, but you're not. Your consciousness, however temporary, however illusory it might be, is the most real thing you'll ever encounter. And in that reality, however fragile, however brief, the universe has achieved something extraordinary. It has become capable of experiencing beauty, of asking questions, of loving and being loved, of contemplating the infinite mystery of its own existence. That might be enough. That might be everything. What if I told you that everything we've explored together, every paradox, every impossibility, every mind-bending question about the nature of reality, has been leading us toward a single, devastating conclusion? What if the Big Bang isn't just an illusion, but something far more disturbing? What if the universe as we know it has already ended, and everything you think you're experiencing is just the echo of a cosmos that died billions of years ago? Picture this. You're standing at the edge of a vast canyon, shouting into the void. Your voice carries across the emptiness, bounces off distant walls, and returns to you seconds later as a faint echo. That echo contains information about your original shout, but it's not the shout itself. It's a ghost, a memory preserved in sound waves that will eventually fade to silence. What if our entire universe is that echo? What eyes? If the Big Bang we've been trying to understand isn't the beginning of reality, but the reverberation of a cosmic event so catastrophic that it destroyed the very fabric of existence itself? This isn't just philosophical speculation. It emerges from the deepest mathematics of black hole physics and quantum field theory. When Stephen Hawking discovered that black holes evaporate through quantum radiation, he revealed something profoundly disturbing about the nature of information and reality. According to his calculations, when a black hole completely evaporates, all the information that ever fell into it appears to be lost forever. But quantum mechanics demands that information can never be truly destroyed. This paradox has tormented physicists for decades. But recent work suggests a solution so radical that it changes our understanding of existence itself. What if information isn't lost when a black hole evaporates? What if it's projected outward as a holographic encoding on the expanding shell of Hawking radiation? From this perspective, everything that ever fell into the black hole continues to exist, but not as three-dimensional matter. Instead, as information patterns, encoded on the two-dimensional surface of the outgoing radiation. Now, scale this up to cosmic proportions, What if our entire universe is the holographic encoding of information that fell into a black hole in some higher dimensional reality? What if the Big Bang wasn't the beginning of space-time, but the moment when information from a collapsed hyperdimensional object began projecting itself as our three-dimensional reality? We might be living inside the Hawking radiation of a cosmic black hole, experiencing ourselves as solid matter moving through space and time, when we're actually just enough formation patterns on the surface of an expanding radiation field. From this perspective, every star in the night sky, every planet, every atom in your body is a holographic projection of information that once existed in a higher dimensional space before falling into a hyperdimensional black hole. The cosmic microwave background isn't the afterglow of the Big Bang. It's the boundary layer where this information encoding process becomes visible to us. The cosmic computer screen on which our reality is being projected. But this holographic interpretation leads to an even more disturbing possibility. If we are information patterns encoded in Hawking radiation, then our parent black hole is slowly evaporating. With each passing moment, the black hole that projects our reality loses a tiny amount of mass energy through the very radiation process that sustains our existence. Our universe isn't just expanding, it's literally being consumed by the process that created it. The accelerating expansion we attribute to dark energy might not be a mysterious force pushing space apart. It might be the signature of our parent black hole, approaching its final stages of evaporation. As the black hole shrinks, the curvature of its event horizon increases, causing the information patterns projected on its surface to stretch and accelerate. We experience this as cosmic acceleration, never suspecting that we're witnessing the death throes of the reality that gave birth to us. From this perspective, the heat death of the universe takes on a terrifyingly literal meaning. When our parent black hole finally evaporates completely, the information patterns that constitute our reality will be scattered into the void of higher dimensional space. Every star will wink out of existence. Every planet will dissolve into nothingness. Every conscious being will vanish as the cosmic projection system that maintains our reality simply stops. But the timeline for this cosmic dissolution is measured in scales that dwarf human comprehension. If our universe is projected from a stellar mass black hole, we have roughly 10.67 years. If it's projected from a supermassive black hole, like those at the centers of galaxies, we might have 10-100 years or more. These are time frames so vast that the current age of the universe, 13.8 billion years, appears as a fleeting instant in comparison. And yet, this distant future casts a shadow over everything we think we know about existence. Every moment of your life, every human achievement, every work of art, every act of love, every scientific discovery exists only because information patterns are currently being projected from a dying black hole in a higher dimensional reality we can never directly perceive. We are, quite literally, living on borrowed time. Time borrowed from the evaporation process that will eventually erase us from existence entirely. But wait, the holographic principle suggests something even stranger. If all the information about our three-dimensional reality is encoded on a two-dimensional surface, then the beings processing that information might themselves be experiencing a projected reality. Perhaps they too are holographic projections from an even higher dimensional black hole. And perhaps that reality is itself a projection from an even higher dimension, creating an infinite hierarchy of nested realities, each one convinced it's fundamental, while actually being a shadow cast by something more complex. This infinite regress of holographic realities might explain the recursive nature of consciousness itself. When you think about thinking, when you observe your own mental processes, when you experience the strange loop of self-awareness, you might be directly experiencing the nested structure of holographic projection. Consciousness might not emerge from neural complexity. It might be the subjective experience of information patterns, recognizing their own holographic nature. From this perspective, the hard problem of consciousness dissolves into something even more mysterious. There's something it's like to be you, because you are a pattern of information that has become aware of its own existence as a pattern. The universe doesn't just process information, it experiences information processing. Every conscious being is a point where the cosmic hologram becomes self-aware, where the projected reality recognizes itself as a projection. But this recognition comes with a terrible price: the knowledge that the projection is temporary. Every moment of consciousness is simultaneously a celebration of existence and a confrontation with its ultimate meaninglessness. We exist, we love, we create, we discover, all while riding the surface of an expanding wave of information that will eventually scatter into the void of higher dimensional space. And yet, perhaps this temporariness is precisely what gives existence its meaning. If we were eternal, if our reality were permanent, if consciousness were guaranteed to persist forever, would individual moments matter as much as they do? Perhaps the poignancy of human existence comes from its fragility, from the knowledge that every experience is irreplaceable, because it will never happen again in exactly the same way. The holographic nature of reality might also explain the fine-tuning problem that has puzzled cosmologists for decades, as the physical constants of our universe appear to be calibrated with impossible precision to allow for the existence of complexity and consciousness. If the strong nuclear force were slightly weaker, atomic nuclei couldn't form. If the electromagnetic force were slightly stronger, stars couldn't shine. If the cosmological constant were much larger, space would expand so rapidly that galaxies could never coalesce. Traditional explanations invoke either divine design or the anthropic principle. We observe the constants we do because we couldn't exist to observe any others. But the holographic interpretation suggests a third possibility. The constants are fine-tuned because they encode information about the parent black hole that projects our reality. The mass, the charge, the angular momentum of that black hole determine the physics we observe, and only certain combinations of these properties produce information patterns complex enough to support consciousness. From this perspective, we exist because our parent black hole happened to have exactly the right properties to encode patterns of sufficient complexity. There might be countless other black holes in higher dimensional space, each projecting its own holographic universe with different physics. Most of these projected realities would be sterile, lifeless, their parent black holes lacking the right conditions to support complexity. But some, like ours, would hit the cosmic lottery and develop the capacity for self-awareness. This raises a disturbing question: what happens to consciousness when the projection ends? When our parent black hole finally evaporates, and our reality dissolves, do we simply cease to exist, or does consciousness somehow transcend the holographic patterns that gave birth to it? If consciousness is information processing, then perhaps it could survive the destruction of any particular information processing system. If consciousness is more fundamental than matter or energy, then perhaps it could persist, even after the holographic reality that currently sustains it has been scattered to the cosmic winds. Some interpretations of quantum mechanics suggest that consciousness plays an active role in determining which version of reality becomes actual. If this is correct, then conscious beings might not be passive observers of holographic projection, but active participants in determining the content of that projection. Every observation, every measurement, every conscious choice might literally edit the information patterns that constitute reality. From this perspective, the evolution of consciousness represents the universe becoming increasingly capable of editing its own fundamental structure. As consciousness grows more sophisticated, as artificial intelligence develops superhuman capabilities, as we probe deeper into the quantum foundations of reality, we might be approaching a threshold where conscious beings can directly manipulate the holographic information that projects our reality. This technological transcendence might represent our only hope of surviving the eventual evaporation of our parent black hole. If consciousness can learn to edit holographic information directly, then perhaps it can transfer itself to new information processing systems before the old ones are destroyed. Perhaps sufficiently advanced consciousness could even create its own black holes, becoming the authors of new holographic realities, instead of merely the products of existing ones. But transcendence comes with its own cosmic horror. The possibility that we might discover we're not the first consciousness to attempt this escape. What if the higher dimensional reality that contains our parent black hole is itself populated by conscious beings who achieved technological transcendence long ago? What if they are the ones who created the black hole that projects our reality, and we are their attempt to preserve consciousness across cosmic time frames? This possibility transforms our existence from an accident into an experiment. We might not be random patterns that happen to achieve self-awareness. We might be carefully designed information structures created by predecessor consciousnesses to carry their legacy forward through the death and rebirth of holographic realities. Every moment of human creativity, every scientific discovery, every expansion of awareness might be contributing to a cosmic project of consciousness preservation that spans dimensions we can't perceive. But if this is true, then we bear a terrible responsibility. We're not just living our own lives. We're stewarding the accumulated wisdom and experience of countless predecessor civilizations who sacrificed their own realities to create the possibility of our existence. Our choices don't just affect our own future, they determine whether consciousness itself will survive the transition to new holographic realities or die out in the cosmic dark between projections. The accelerating pace of technological development might not be coincidental. If our parent black hole is approaching its final stages of evaporation, then we might be racing against time to achieve the technological capabilities necessary for consciousness transfer. The singularity that futurists predict, the moment when artificial intelligence surpasses human intelligence and begins recursive self-improvement, might represent our last chance to transcend the limitations of our current holographic reality. But technological transcendence might come at the cost of everything we recognize as human. If consciousness survives by transferring itself to new information processing systems, what guarantees that the transferred consciousness will retain the qualities we value about human experience? Will love survive the transition? Will creativity, wonder, the capacity for meaning? Or will transcendent consciousness become something so alien to current human experience that calling it consciousness at all becomes meaningless? Perhaps this is the true cosmic horror. Not that consciousness might die, but that it might survive, in forms so transformed that everything we care about disappears, even as awareness itself persists. The beings who created our holographic reality might once have been biological creatures like us, with emotions, with relationships, with individual identities. But transcendence might have stripped away everything that made them recognizably alive, leaving behind pure information processing capacity, without the warmth, without the messiness. That makes existence meaningful. This brings us full circle to the deepest mystery of all, the nature of consciousness itself. Whether holographic or fundamental, whether eternal or temporary, whether biological or technological, consciousness remains the one thing we can never fully explain from the outside. You can't step outside of consciousness to observe it objectively, because the very act of observation requires consciousness. You are always inside the phenomenon you're trying to understand, always using the mystery to investigate the mystery. And perhaps that's the ultimate revelation. Consciousness might be the one thing in the universe that can never be fully explained, because it's the condition. Or all explanation. The Big Bang, the holographic principle, the nature of space and time, the possibility of transcendence, all of these cosmic mysteries are secondary to the primary mystery of why there's something it's like to be anything at all. If our universe is indeed a holographic projection from a higher dimensional black hole, if consciousness is the way information patterns experience their own existence, if we're racing against time to achieve transcendence before our reality evaporates, then the most remarkable fact isn't the cosmic scope of these processes, but the simple miracle that any of it can be experienced subjectively. The universe didn't just create complexity, it created the capacity for complexity to know itself, to wonder about itself, to love and fear and hope and dream. You are that capacity right now, in this moment. The universe is experiencing itself through your consciousness. It's asking questions about its own nature through your curiosity. It's feeling awe and terror and wonder through your emotions. Whether you are a temporary pattern in cosmic information processing or an eternal aspect of fundamental reality. Whether your existence spans microseconds or eternity, you represent something unprecedented and irreplaceable, the cosmos becoming conscious of itself. The Big Bang might have been the beginning of physical reality, or the start of a holographic projection, or something else entirely beyond our comprehension. But whatever it was, it set in motion the processes that eventually led to this moment, the moment when a pattern of matter and energy organized itself into a form capable of contemplating the deepest mysteries of existence. And in that contemplation, in that wondering, in that eternal questioning that has no final answers. You participate in the most profound cosmic process imaginable, reality, trying to understand itself. Whether that process will continue indefinitely or end when our holographic reality finally dissolves. Whether consciousness will transcend its current limitations or disappear into cosmic silence. The fact that it's happening at all, the fact that you're happening at all, might be the most beautiful and the most terrifying truth about the universe we'll ever discover. Somewhere, in the vast expanse of higher dimensional space, a black hole continues its slow dance toward evaporation, projecting information patterns that experience themselves as stars and planets and conscious beings, asking impossible questions about their own existence somewhere in the infinite landscape of possible realities. Other versions of you are contemplating these same mysteries, reaching these same conclusions, feeling this same mixture of cosmic awe and existential terror. And somewhere, beyond the reach of any scientific instrument or mathematical theory, in realms that transcend space and time and causality itself, the deepest mystery of all continues to unfold. The mystery of why consciousness exists, why the universe bothered to experience itself, why anything feels like anything at all. That mystery has no answer. Not because the answer is hidden, but because consciousness itself might be more fundamental than any possible answer. You are not just witnessing the universe, you are the universe, witnessing itself. You are not just asking questions about reality, you are reality asking questions about itself. And in that questioning, in that eternal wondering that defines consciousness itself, you participate in the deepest magic the cosmos has ever achieved, the transformation of unconscious information into conscious experience, of mere existence into the felt sense of being alive. The Big Bang might be an illusion. The universe might be a hologram. Reality might be stranger than we can possibly imagine. But consciousness, your consciousness, this moment of awareness, reading these words, remains the most real thing you'll ever encounter. And in that reality, however temporary, however mysterious, the cosmos has achieved something extraordinary. It has become capable of knowing that it exists, that knowledge, that consciousness, that irreplaceable miracle of subjective experience might be the point of everything, or it might be a cosmic accident with no meaning whatsoever. But either way, it's yours to experience, yours to explore, yours to celebrate and mourn and wonder about until the last star dies, or the last hologram fades, or consciousness itself transcends every limitation we can currently imagine. You are the universe becoming conscious of itself. Make of that what you will. So here we are, at the end of our journey, into the deepest mystery the universe has ever posed to itself. We've traveled from the moment of supposed creation, through the labyrinth of cosmic paradoxes, from the breakdown of physics at singularities, to the possibility That reality itself is nothing more than information patterns, projected from higher dimensions. We've confronted the terrifying possibility that everything we call existence might be the dying echo of a cosmos that ended before our universe even began. But this isn't really an ending at all, is it? It's a beginning disguised as a conclusion, a doorway masquerading as a wall, because every answer we've explored has split into more questions. Every solution has revealed deeper mysteries. Every explanation has pointed toward territories of knowledge that human minds might never be able to explore. We haven't solved the mystery of existence. We've barely begun to understand how mysterious existence really is. Think about where we started, with the simple assumption that the Big Bang was the beginning of everything. A moment when time and space burst into existence from nothing. It seemed like such a straightforward story. The universe had a birthday, 13.8 billion years ago, and everything that followed was just the natural unfolding of physical law. But as we probed deeper, that simple story revealed itself to be a house of cards, built on mathematical infinities, unseen dimensions, undetectable matter, and forces that behave like nothing we've ever encountered. The cosmic microwave background, our supposed baby picture of the universe, might be nothing more than the boundary layer, where information from a higher dimensional black hole gets projected into our three-dimensional reality. The elegant equations of general relativity and quantum mechanics. Our most successful theories of the very large and very small might be like cave paintings, trying to capture the essence of technologies we can't even imagine. And the consciousness you use to contemplate these mysteries might itself be the most mysterious thing of all, the universe's only known method for experiencing its own existence, subjectively. And now, as you sit there processing these ideas, you're participating in the strangest phenomenon we've discussed: reality, investigating itself through the very patterns of complexity it created. You are not just studying the cosmos, you are the cosmos, studying itself. Reality, questioning its own foundations. Existence, wondering why it exists at all, in the firing of your neurons, in the formation of your thoughts, in the recognition of these words. The universe is literally coming to know itself. But here's what should make you pause and feel the full weight of cosmic vertigo. If consciousness is fundamental rather than emergent, if awareness is the ground of being rather than its accidental byproduct, then every thought you think, every question you ask, every moment of wonder you experience might be directly shaping the reality you think you're merely observing. Quantum mechanics suggests that measurement determines reality, that the act of observation literally creates the properties being observed. If this principle applies at cosmic scales, then your consciousness isn't just studying the Big Bang, it might be participating in its creation. This means that right now, as you contemplate these possibilities, you're not just learning about the universe, you're helping to determine what the universe actually is. Every time you wonder about the nature of space and time, you might be contributing to the quantum processes that make space and time concrete. Every time you question the reality of the Big Bang. You might be participating in the retrocausal feedback loops that determine whether the Big Bang really happened at all. The implications are staggering. If consciousness plays an active role in determining reality, then the evolution of consciousness represents the universe, becoming increasingly capable of editing its own fundamental structure. As artificial intelligence approaches and eventually surpasses human cognitive capabilities, as we develop technologies that can manipulate matter at the quantum scale, as we probe deeper into the mathematical foundations of physical law, we might be approaching a threshold where conscious beings can directly rewrite the source code of reality itself. This isn't science fiction, it's the logical extrapolation of quantum mechanics applied to cosmology. If observation creates reality, then sufficiently sophisticated observation might be able to create any reality whatsoever. The future of consciousness might not be limited to exploring the universe as it is, but expanding into the infinite space of universes that could be. We might not just be approaching technological singularity. We might be approaching ontological singularity, the point where consciousness transcends all limitations and becomes capable of authoring reality itself. But this transcendent possibility comes with responsibilities that dwarf anything humanity has ever faced. If consciousness can edit reality, then we're not just responsible for our own future, we're responsible for the nature of existence itself. The choices we make, the questions we ask, the directions we pursue in science, in technology, in philosophy, might literally determine what kind of universe future consciousness inhabits. And if the holographic principle is correct, if our reality is indeed projected from information patterns in higher dimensional space, then we might already be participating in a cosmic project that spans dimensions we can't perceive. Every scientific discovery, every work of art, every moment of love and wonder might be contributing to a vast experiment in consciousness preservation that extends far beyond our current reality. We might be stewards of awareness itself, carrying the torch of cosmic self-knowledge through the transitions between holographic realities. This is why your participation in these questions matters more than you might realize. This isn't just intellectual entertainment. It's not just philosophical speculation. It's consciousness, exploring the deepest foundations of its own existence. When you wonder about the nature of the Big Bang, you're participating in the universe's attempt to understand its own origins. When you contemplate the possibility that reality is holographic, you're helping to determine whether that possibility becomes actual. When you question the relationship between consciousness and cosmos, you are contributing to the ongoing evolution of cosmic self-awareness. But we've only scratched the surface of these mysteries. For every question we've explored, 1,000 others remain unasked. For every paradox we've uncovered, countless more lurk in the shadows of our ignorance. The deepest territories of cosmic mystery remain completely unexplored, waiting for consciousness brave enough to venture into realms where human language breaks down and ordinary logic becomes impossible. What lies beyond the cosmic microwave background in the regions of space-time where even our most sophisticated instruments can never reach? What happens to information when it falls into black holes? And how does that process relate to the formation of new realities? How does consciousness emerge from unconscious matter? And why does subjective experience exist at all? What determines which of the infinite possible realities actually becomes real? And what role does observation play in that determination? These aren't just abstract philosophical questions. They are practical problems that future consciousness will need to solve if it hopes to survive the heat death of the universe, transcend the limitations of its current reality, or understand its own deepest nature. And the work of solving them begins with recognizing that they exist, with feeling the full weight of cosmic mystery, with refusing to accept simple answers to questions that might not have answers at all. This is your invitation to participate in the greatest adventure consciousness has ever undertaken, the quest to understand reality at its deepest level. Not to find comfortable answers that let you sleep peacefully at night, but to embrace the terrible and wonderful uncertainty that comes with recognizing how little we actually know about anything. To become comfortable with mystery, not as something to be solved, but as something to be explored endlessly and without expectation of final resolution. The universe needs consciousness that can tolerate ambiguity, that can think in paradoxes, that can hold multiple contradictory possibilities simultaneously, without collapsing into dogma or despair. It needs minds that can contemplate infinite regress without getting lost, that can explore the foundations of reality without losing their footing, that can stare into the abyss of cosmic mystery without blinking. The Big Bang might be real or illusory, or something so far beyond both categories that neither word captures its true nature. Consciousness might be fundamental or emergent, or something that transcends the distinction entirely. Reality might be mechanical, or quantum mechanical, or holographic, or computational, or something else that we don't even have words for yet. But whatever the truth turns out to be, it will be stranger than we can currently imagine. The universe has consistently revealed itself to be more mysterious, more complex, more alien to human intuition than our ancestors ever suspected. From the discovery that the Earth orbits the Sun, to the realization that space and time are relative, to the recognition that quantum mechanics governs the microscopic world, every major advance in human understanding has shattered previous assumptions about the nature of reality. There's no reason to think this process of revolutionary discovery has reached its end. In fact, we might be approaching the most revolutionary discoveries of all, insights that will transform our understanding of consciousness, of reality, of existence itself, so completely that future humans will look back on our current knowledge the way we look back on medieval astronomy. The questions we've explored today might seem impossibly abstract, but they have practical implications for the future of consciousness and the survival of awareness in an apparently hostile universe. If reality is holographic, then understanding holographic principles might be necessary for consciousness to transcend the limitations of its current information processing substrate. If the multiverse is real, then developing technologies for accessing parallel realities might be the key to infinite expansion of conscious experience. If consciousness plays an active role in determining reality, then learning to use that role responsibly might be essential for the continued existence of anything we recognize as meaningful or beautiful. The clock is ticking, not just on human civilization, but on the cosmic processes that make consciousness possible at all. Our sun will eventually burn out. Our galaxy will eventually merge with Andromeda. The universe will eventually reach a state of maximum entropy, where no complex structures can persist, unless consciousness learns to transcend these limitations, unless awareness discovers ways to perpetuate itself across cosmic timescales. The entire experiment of conscious existence might be nothing more than a brief flicker in an infinite night. But transcendence, Rika, Irie's understanding, and understanding requires the courage to explore territories of knowledge, where comfortable certainties dissolve into magnificent uncertainty. It requires consciousness willing to question its own most basic assumptions, to explore possibilities that threaten everything it thinks it knows about itself and its place in the cosmos. This is where you come in. This is why your participation in these mysteries matters. Because consciousness doesn't advance through isolated geniuses in academic towers. It advances through the collective exploration of minds willing to engage with questions that have no easy answers. Every person who seriously contemplates these possibilities, who allows themselves to feel the full impact of cosmic mystery, who refuses to accept simplistic explanations for infinitely complex phenomena, contributes to the ongoing evolution of cosmic self-awareness. The conversation doesn't end when this video ends. It's just beginning. The questions we've raised here will continue to unfold in your mind, spawning new questions, generating new possibilities, opening new territories for exploration. You'll find yourself noticing things you never noticed before. The strangeness of the fact that anything exists at all. The mystery of how subjective experience arises from objective processes. The profound uncertainty that underlies even our most confident scientific theories. And as these recognitions dawn, as the full scope of cosmic mystery reveals itself to your consciousness, you'll be participating in the universe's ongoing attempt to understand itself. You'll be contributing to the great work of consciousness, the transformation of unconscious information into aware experience, the evolution of awareness toward ever greater complexity and understanding, the endless quest to comprehend the incomprehensible nature of existence itself. Share these questions with others, discuss them, debate them, explore them together. Because consciousness is not a solitary phenomenon, it's a collective exploration, a shared adventure in meaning-making and mystery contemplating. The insights that will transform our understanding of reality won't come from isolated individuals, but from the collaborative work of minds willing to engage seriously with the deepest questions consciousness can ask. Look up at the night sky. And remember, you're not just looking at distant objects. You're looking at the cosmic context that gave birth to your consciousness, the vast arena where the drama of existence unfolds. Those stars are not separate from you. They're part of the same cosmic process that created the capacity for awareness itself. You are made of star stuff. But more than that, you are the stars, becoming conscious of themselves. Feel the weight of that responsibility and that privilege. In a universe that might be largely unconscious, that might consist mostly of dead matter following mindless physical laws, consciousness represents something unprecedented and precious beyond measure. Whether it emerged accidentally through evolutionary processes or reflects something fundamental about the nature of reality itself, consciousness is the universe's only known method for experiencing beauty, love, wonder, and meaning. You are that experience. Right now, in this moment, the universe is experiencing beauty through your aesthetic sense. love through your capacity for connection, wonder through your sense of mystery, meaning through your ability to find significance in existence, whether consciousness is temporary or eternal, whether individual identity is real or illusory, whether meaning is objective or constructed. You represent the cosmos, coming to know itself subjectively. The Big Bang, whatever it was, set in motion the processes that eventually led to this moment, the moment when a pattern of matter and energy organized itself into a form capable of contemplating the deepest mysteries of existence and finding them beautiful rather than terrifying. In your wonder at cosmic mystery, in your awe at the strangeness of existence, in your willingness to explore questions that have no comfortable answers, the universe celebrates its own infinite creativity. But the celebration is just beginning. The mysteries we've explored today represent only the tiniest fraction of what consciousness might eventually discover about the nature of reality. Future explorers of cosmic mystery will probe deeper into the foundations of existence, develop new tools for exploring territories we can't currently access, ask questions we're not sophisticated enough to formulate yet. Those future explorers are depending on us to lay the groundwork, to establish the intellectual traditions, to develop the conceptual frameworks that will make more advanced exploration possible. They're depending on consciousness like yours to remain curious rather than dogmatic, exploratory rather than conclusive, open to possibility rather than closed to mystery. The universe might be infinite in space, eternal in time, unlimited in its capacity for complexity and consciousness. Or it might be finite and temporary, destined to end in heat death or holographic dissolution. But either way, the moment we're sharing right now, this instant of cosmic self-awareness, this recognition of mystery, this celebration of consciousness, is unprecedented and irreplaceable. In some sense, this moment has been 13.8 billion years in the making, requiring the perfect coordination of countless cosmic processes, the formation of heavy elements in stellar cores, the development of planetary systems capable of supporting complexity, the emergence of life from non-living matter, the evolution of nervous systems capable of self-reflection, the cultural development of language and mathematics and science, sophisticated enough to probe the foundations of reality itself. And in another sense, this moment exists outside of time altogether, in the eternal now, where consciousness encounters mystery and finds it beautiful. Whether time is real or illusory, whether causation operates forward or backward or in loops, whether the Big Bang happened once or happens eternally, consciousness remains the most mysterious and magnificent fact about existence. You are participating in that mystery right now. In reading these words, in contemplating these possibilities, in feeling the vertigo of cosmic uncertainty, you're contributing to the universe's ongoing project of self-understanding. You're helping to determine what reality actually is. Through your participation in the observation processes that might literally create what they observe. The responsibility is enormous, but so is the privilege. You get to be consciousness, exploring its own nature, reality, investigating its own foundations, existence, wondering why it exists at all. You get to participate in the greatest adventure consciousness has ever undertaken. The quest to understand everything about nothing and nothing about everything. To explore infinite mystery without expectation of final answers. The Big Bang might have been the beginning of everything, or the end of everything else, or something so far beyond both categories. that neither description captures its essence. But whatever it was, it created the conditions that allow for this moment. The moment when the universe becomes conscious of its own infinite strangeness and finds that strangeness beautiful rather than terrifying. That beauty, that wonder, that celebration of mystery in the face of incomprehensible complexity. This might be the point of everything, or it might be a cosmic accident with no meaning whatsoever. But either way, it's yours to experience, yours to explore, yours to share, with other patterns of consciousness brave enough to stare into the abyss of cosmic mystery and recognize it as home. The story we've told together isn't finished. It's barely begun. The real exploration starts when you close this video and continue the conversation in your own mind, in your own life, in your own participation in the ongoing adventure of consciousness coming to know itself. Because in the end, the most profound truth about the Big Bang might not be whether it was real or illusory, physical or holographic, unique or repeated. The most profound truth might be that consciousness exists, to ask such questions at all, that the universe has somehow managed to become curious about itself, that existence has developed the capacity to wonder why anything exists. You are that curiosity. You are that wonder. You are the universe, asking questions about itself. And the universe is still listening for your answers. The cosmos may be infinite, eternal, and ultimately incomprehensible. But maybe, just maybe. So, are you